Hi, I was calling because we're going to be starting a I guess so make sure you guys log on to the website, complete the attendance on there. Okay, so we're gonna see. Looks like we got some new students, so that's good. I reached out to them, so we're waiting for everybody to log on. Go ahead and fill out the attendance form on the website, and we'll get started here momentarily. Oh, haven't said anything. It was on silent. Nobody was saying anything. Just giving everybody a moment to log on. We got some new students that are joining, so I'm happy to see everybody's here because I push CSN, letting them know that if there's students that are not here that are not participating, but they're on the books, that we should still get new students. So glad to see everybody that's logging on. That's how you keep your spot. So we'll give them a few more minutes. Oh, and while we're waiting for that, remember to please fill out your attendance on the website. And as we're waiting as well, I also want to point out that if you subscribe on the channel, it makes it so you get all the new videos. So you don't have to worry about me necessarily sending the link. So, so we should have a few more people joining us. Okay. All right. Just about to send her a message. Okay. Thank you for joining us. So we need a few more. Okay. Sending out a few. Look at the remind message as well. So a few more people saw it. Okay, so if you're on the video, I'm gonna send one more message to everyone, letting them know that we're starting. Because again, I keep track of the numbers. They're continuously adding students. So if people are not participating, I'm gonna let them know to put in more students, no matter how many students are on the books. So So I'm gonna try one more person, then we're gonna be jumping into the equations. And we'll talk about the results of the quiz. Um, let's see. My connection today seems to be a lot better than yesterday. Okay, I'm gonna send out one more message on remind. Okay, so we're at the 7. Okay. So we got about, I know there's like about two people who are also looking to join. We're going to go ahead and get started. So the first thing we're going to talk about is the fact, okay, so attendance obviously needs to be strong. And I know I'm preaching to the choir because everybody here obviously doesn't have any problems. But I just want to, again, let it be known that we talked to other people who are supposed to be in this class that um, if we're not participating, then again, other people will come in. Okay, we just had somebody else join. Awesome. And my goal is to have everybody in here participating, working, and passing the test. Okay. We definitely need this. So if you talk to your friends and like, oh, I'm going to kind of join and then I'm really making an effort, then again, I'm going to push for other people who really want to be in the program to take those seats. I understand you're busy. I probably have, I don't even know how many meetings a day. So what I would recommend is if there's a day where you can listen, that's still better than not participating at all. A lot of you are diligent on sending me a message, hey, I'm in the store, whatever. That's fine. As long as you then are at least listening, then I would know that and I won't, press you for questions or answers or anything like that. But if you're not participating, then you're not going to get anything out of the class. So I just want to put that out there again. We're going to put the number up for the conference call so that everybody can utilize that for questions. We're going to continue to talk about equations, and we'll talk actually a little bit before that. We're going to talk about the results of the quizzes, but math wise, we're going to be moving on to equations. Put this number up here. And I'm going to send this in the chat box as well. All right. So please, I would like everybody. That's okay if you get a chance to do the third quiz. So yes, I would like everybody to go ahead and join the conference call again. Although YouTube seems to be reliable today, it's not always reliable. And when we're working on these equations, it can take a while for us to solve them. And trying to type in questions as I'm working is not going to be as effective. So I'd like everybody on here to join the conference call.
Good morning.
Good morning.
Morning.
Morning. Awesome. All right. So as you join, please make sure to mute your phones. The other reason why we use YouTube and the conference call, it's not as intense on the internet. So we're using two different forms. So I know it can seem a little antiquated, but there's so many meetings I've gone to where the meeting has to end early or it gets canceled because somebody's computer can't handle streaming and the audio and everything else. Wait for everybody to log on. Remember, please mute your microphones. Okay. So the first thing we're going to talk about, since it looks like we have everybody here, the first thing that we're going to talk about is the results of your quizzes. So this was mostly ELA and writing, and what we're going to do now is just very briefly talk about how everybody did, and then we're going to move on to equation word problems. Okay, I think everybody's on. Okay. So, in looking at the quizzes, and again, these are quizzes that were given before in class. I hope everybody took it seriously and nobody was like Googling the answers or anything like that, because that's not going to be a benefit to you. But in looking at
Can't
these,
hear anything.
Yeah, me too.
can you hear me now?
Yeah. Oh, yeah. Hit now.
Okay, yeah, sorry.
Wow. Okay.
Okay. All right, so we got 11 people. All right, awesome. Okay. So, in looking at the quizzes, and again, these are quizzes that every other class has done before. So if you did well, then you know you're going to be in good company. And again, I hope you took it honestly, so that's how you know. So for the compilation, this is a combination of pretty much everything we're ever going to do in reading and writing. The class average was 80%. Okay, and that's good. So let's look here. In fact, the lowest score was a 71%. Last time, I mean, over the course of almost 2 years, the people that have taken this test, I think I've had at least 3 people a class pass the entire GED, if not the majority of the GED or TASC or high set. So it's a benefit that the class average is very high. That also lets me know that we could probably have a faster pacing for English, for English language arts and writing, because everybody did so well. Any questions on that?
No question.
No
I
question.
have a question.
Okay, go ahead.
So I see I'm on your YouTube live. Do I need to be on the conference call as well as the YouTube live?
Yes, because once we start working,
everything.
uh-huh.
Yeah. Okay. Yeah, 'cause you're gonna be working on the board, right?
Yeah, I'm working on the board, and that way, if you have a question, you don't have to type it in because it can be kind of intricate. So it's better for you to say, "Hey, I don't understand," and then we walk it through that way than it is to, yeah.
Okay.
Yeah. Perfect. Okay. And then, okay, now on the compilation, part 3, we ended up with a class average of 65%. So that's a little concerning, but this is something they would do obviously at the end of class. Although some people did get 100%. And actually, you know what? There's 2 people that did not finish. That's probably going to end up bringing down the average. Let me delete those out of the test. Okay. Okay. So once I've deleted those 2, wow. So after deleting those 2, that brought the class average up to 83%. So as far as ELA and writing, all of them that have proven that we're doing well. Even compilation 4, which is the ELA language arts, or the ELA and writing standards that we covered towards the end of the year, the class average was 77%, which is still good, considering the fact that these are our standards that we'll cover like right before the test. Okay. and we had 2 students get 100% on that test. So that's excellent. So what we're going to do now is we're going to be talking about word problems that have equations, otherwise known as equation word problems. Word problems are probably, and they exist in all forms for all levels of math and all areas of math. They're probably the area that I see students struggle with the most because it's as much of a reading test as it is a math test. And I know that's not always easy. So we're going to talk about some strategies, and I'm thinking about rewriting it on the board, just so that I know what everybody's using in a live chat, or you could tell me through the conference call. Let me know if you have the ability. If I were to send you a link for a separate program, if you have the ability to work in that separate program, or if it would be easier for me to use a whiteboard. Because I know some people have me like on a phone and on a tablet or a laptop, so it might be easier for you. And some people are only using a phone. So if you could let me know through the live chat or to the conference call, if you'd be able to work on a separate program. Give everybody a second to do that.
So if I'm responding to what you asked, I'm responding to you through.
Yeah, either way is fine. There's many different ways. So somebody said no, so they're using a cell phone. Someone else is using a laptop. So I haven't heard from everybody. So I've heard from Brandy, heard from LD, but I have not heard from Sam. I have not heard from Lillian. Haven't heard from Mariana. Haven't heard from Andre. So need the whiteboard on a laptop.
Yeah, I use my laptop or my phone or any device. I have all device that we need to. I need to get up the class, but it's visually is better for me because this English is not my first language, and sometimes I miss some words, some idioms, some audios. So I can my listen in a conference call, but sometimes I miss some words that you say. You understand?
Okay.
It's really hard to me to get the class on a conference call and know when I can see the, for example, a whiteboard or your expression.
Okay, and what is your first?
I'm here to learn this, to work in this, and I have a little gift. 1 year, it's hard to listen to hear.
Yeah. What is your first language?
I said this.
What's your first language? What's your first language?
My first language is Portuguese. I'm here to learn about English, and I have English as my second language.
Okay. So if I spoke some Spanish, some of it would make sense, right? Because as we start working, that might be like a tool that I might utilize.
but Spanish is not work for me.
Yeah, I know. Like sometimes it sounds similar.
Spanish is not very close to Portuguese. People, they have very similarities in principles, but they're not very close. So
Yeah, because when I hear people speaking Portuguese, I can understand them.
yeah,
But that's okay. I'm used to learning English.
Yeah, because the other thing too is that
Spanish or any one language, okay. But I think we having to wasting time and decide about this with YouTube or conference call and pass 30 minutes.
yeah, so we do that. We do that because we do that because not everybody has access to the same level of technology. So we spend a lot of time making sure everybody can access it and seeing what they're using so that when I send out a program, it's all the same for everybody. Does that make sense? So I can't assume that like everybody has a computer or that everybody has like a laptop or a tablet. Some people only have a phone. In fact, things are so bad with it, the university or the college is going to be providing people with a tablet and a cell phone. So that's why we do things like that. Yeah, because if I were to just say, hey, everybody has to use Zoom, and then not everybody has a device that's like capable with that, or not everybody can sign on, then not only would we not be starting class, we wouldn't have a class period because there's issues with people like with their emails and things like that. So the conference call is so that you can't just listen to me in the background and then not participate. It's the same thing with Zoom. Some people just sit there, they stare, and that's not how I teach. That's why 80% of my students have growth on the test, and I had the highest rate of people passing the high set. So it's because I want everybody to be involved.
Okay. In my last class at CSN, when I started the lockdown, we finished the course student by Zoom, and it works well. All the guys using the laptop or their cell phone.
How many of those guys took the test? How many of those guys took the test? Because if the last class went really, really well, because right now you're a 4 or you're a 5, meaning that you're really close to passing. So the purpose of the last class would be to not have another class where you guys would take the test and pass it. So that's what I mean. Like, I don't want somebody to complete this course and just use any technology. I want you guys to complete this course, take the test, and pass. And that means that you have to participate. That means that you have to speak up. That means you have to let me know you have a question. That means you should be able to walk through all the problems. So like, I pride myself more on people finishing the class and passing the test than the technology itself. So like, for example, the problem I'm going to put up on the board here is going to be something that if you're comfortable and confident, you should be able to actually walk through completely either on your own or with little assistance from other people. So that's why I don't necessarily like using Zoom or anything else like that, because people can kind of get away with not participating, and it's heavy on the internet. Does that make sense?
Yeah, that's okay. That's okay. This is really, really confusing because we have a website with all things about the course. We need to watch email because the links.
The website.
Live at YouTube, the conference call.
The website is just for you guys to do attendance.
A lot of ways. To get a class, we have 4 or 5 ways, different ways.
Yeah, the website is just. Okay. Yeah, no. I want to address your concerns, man. The website is for you just to do attendance, and I post up videos there. So after you're done with the class, you can watch the videos. That's the purpose of the website. The website isn't there for you guys to necessarily go on to get instruction as I'm doing it. It's so that if you have a question, you can log on to the website and look at the video. It's so that when you do attendance, it goes over to the advisor who calls people who should be here. So that's why we have the website. because Mike, he's not going to join every Zoom call when people don't show up to figure out who's there. And if I send him messages every single day saying, "Hey, here's who's present in class and here who's not," that also wastes class time. So that's why we have the other website. That also goes to his boss. So everybody at CSN is well aware of the time that you guys spend in class. That's why we have those. It also has something on it called Google Analytics, which tracks wherever you are on planet Earth. So we can also get analytics on where you are in Vegas, how long you're on it, what device you're using to access it, because we use that information to buy devices for students. And to have another company do that costs money. Google Analytics does it for free. That's why we use that. Does that make sense? So it's not just about a program. It's about,
I got it.
yeah. No, hey, like I said, if you think something could be better, speak up, man. I'm all for it. My goal is for everybody to pass, and there's a method to everything that I do. That's why we're also working on the word problems today. And if English is not your first language, one of the first things that I would recommend is when we're talking about taking notes on these problems, is that the notes do not have to be in English. So when we're close reading, one of the advantages that we have is that it's for us. So if you feel more comfortable putting it in another language, that's why I ask, that's a good tool to use. That's something that can help you with the essays, help you with the reading, and also help you with math. Okay, what?
Thank you, teacher, but I think no need. I'm here to learn in English. I need to speak more, a little bit more.
Yeah,
But
so yeah, this class here, the purpose of it is for you to pass the HiSET, right? So if you're taking like let's say you're writing an essay. If you're writing an essay and you're reading a text and the text is argumentative, like the text is trying to get you to prove why we should or should not have uniforms in school, it's better for you to take the notes in your own language and do your essay obviously in English. But if you take the notes in your own language, you're going to be able to synthesize the information, like look at what you read, look at the video, and translate that better into the essay. So that's why I recommend when you're looking at the actual text that you're going to be reading, to take notes in whatever language is going to make you comfortable. Does that make sense?
Mr. Mora,
Mhm.
this is not my point.
This is not. What's that?
My point is I'm here in class, okay, to learn English.
No, you're here to pass the test. I'm not an English. I'm not a English language proficiency teacher. No, that's not why you're in the class. My goal is not to teach you English. My goal is to teach you how to pass the test.
To get my diploma HSE, I have one appointment for my HiSET test, but I can't do this test because it's locked out. But the device is hard to listen because it has a lot of noises, a lot of.
If you need an English class, if you need an English class, I can recommend you for an English teacher. We do have English teachers, English language learner teachers, but that's not what I teach. If you're in this class, it's because you got a 4 or a 5. So we shouldn't be in this class trying to be more proficient in English.
I need to talk about this with Mr. Fink.
Yeah, we can set up a call with him. Yeah, we can set up a call with him.
Because I misunderstand that happened about this. My last course at CSN works out really well. We have one place that's a Google Classroom and conference at Zoom and work well.
I'm glad that class worked well for you. And there's also a reason why they put you in this class.
That's okay. Okay.
So I mean, there's
Can I ask
that.
a question? Can I ask a question?
Yeah. So because we're about to jump into the word problem here. Go ahead. Go ahead. What was the question?
Yeah. So, you do reading and math. So this reading that you're teaching, it's basically what's going to help facilitate just passing the GED.
Correct. The high
Right?
set GED.
Just like the math. So, I know where you're coming from with that. Whenever you're placed, if you took a test or anything like that, and you were placed in this, it's just to help you get your GED, your basics. That's what I know you're trying to explain that to him. And but so for me, I didn't pass. The only thing I didn't pass was the math. So I'm just everything's clear on this end. You're really clear. I'm ready to begin this. So
Yeah.
I just wanted to
Yeah, absolutely. Yeah, and I think that if the only thing you needed was the math, I feel pretty good that after this class you'll end up passing once they open up the test centers. And I actually have the word problem up on the board. So we're going to begin with what equations are and then how to approach a word problem. Okay. So one of the common mistakes that I see people making when they approach a word problem is trying to keep all the facts in their head. So the first thing that we're going to do is as we read, and I know it might be a little hard to see, so I'm going to be reading it word for word out loud. A lot of the messages that I got said that the whiteboard would be easier than sending out another program. So I'm going to make sure that we take advantage of that. So 2 houses are for sale on the same street. The second house has 1,000 square feet. So as I'm reading, one of the things I like to do is, and this is something that with whatever version of the high school equivalency test you take, the high set, TAS C, GED, you should be allowed to write actually on the questions. They're pushing for that. If not, you have a separate sheet of paper. But I believe in actually writing on, right? So we're talking about 2 houses are for sale on the same street. Okay, so we're talking about 2 homes. This is important to do because in these math problems, they're going to be assuming that you know what it's like to own a home. So I've seen problems where they talk about things like mortgage insurance and people don't know you pay that every single month and stuff like that. So by putting a box on this, highlighting it, I'm letting myself know that we're talking about purchasing a home, right? I might even write that out, purchasing a home. It's going to seem like we're going to take a while on the problem, and we will. You're not going to have a lot of these word problems to the point where it's going to eat up your time, but as we practice this, we get better. The second house has 1,000 square feet. I'm going to write that T. 1,000 square feet less than twice the square feet of the first house. Okay, so the second house has 1,000 square feet less. So I'm going to go ahead and write that out. 1,000 square feet less than twice the square feet of the first house. So whatever the first house is, it has 1,000 square feet less than twice the square feet of the first house. So it's going to be twice the square feet of the first house, and then 1,000 after that. So we know we're going to be getting an equation, okay? And then in this equation we have variables. Variables meaning they're letters that stand for a number that we don't know. So the goal here is to write out the equation and then solve it. So if we want to represent both houses with different variables, to say like house 1 could be A, house 2 could be B. Notice as I'm writing it out, I'm starting to build that. Question so far?
What is the question on the bottom? I can't read it.
Oh, I'm going to read it out loud. I'm going to read it out loud. I ran a little bit out of space, but it's saying, what is the square footage of the house? So the whole question is, together, the houses have 4,400 square feet. what is the square footage of the house?
Each house or the first house.
Yeah. Together, the houses have 4,400 or 4,400 square feet. What is the square footage of the first house?
Hello?
Yes. Were you able to hear that last part?
Yeah, you. Do we just take the 1,000 square foot away from the 4,400?
Yes. But we need to set up an equation so that we can look at how to solve it. Does that make sense?
Yeah, so we're going to do equal 4,400?
There we go. Yes. So we know that when we set up our equation, the first house is 2 times what the second house is, and the second house is $1,000 less, and it all has to equal 4,400 or 4,400. So the question is, what is the square footage of the first house? Because the second house has 1,000 square feet less than twice the square footage of the first house. So the second house has to be $1,000 less than double the amount of the first house. Okay, so I'm hearing a little bit of silence. So if you have a question on this, or if you feel like you're completely lost, go ahead and just let me know on the conference call. Because I'm going to erase this since I know everybody heard it, and we're going to actually write out the equation. So if you're lost.
So is it going to be 5? Oh, wait, are we answering it?
Yes, we need to answer. I'm going to erase it so we have some space. I just want to know who has a question on it so far. If you're lost or if you feel like you're ready to set up the equation.
So I just did it like so 5,400. So you minus that 1,000, so it comes out to 4,400. Or figures it out.
Okay, so that's what you got as the square footage of the first house? So because this one's going to be a little tricky, and this is what makes the word problems difficult. We're trying to figure out the square footage of the first house. So what we have to do in a situation like this is we have to actually set up an equation. So you know how we've been working on equations and there've been random variables or letters and we've been equaling something? Ooh, Miss Sam. Very nice. Go ahead. You're on the right track. It's the equation is going to be a little different, but I like where your mind went. So you're not completely off. You just have an extra variable in operation. But good. Okay, and I'm sorry, I was just talking to someone who had a question.
Okay.
Sorry, the student who just was asking about how to set it up. Hello?
Yeah, hi.
Okay, yeah, so sorry, what were you saying?
Well, the way I set it up, I was a little confused, but all I did was okay, what? So there's already 1,000. We know there's 1,000.
Yep. So we know there's 1,000.
It equals 4,400.
Yep.
So all I did was add those both together to get the answer. To get the 5,400. That's what I did. Because if you minus 1,000 from 5,400.
Okay, yeah. So and here's the one thing you want to keep in mind is that all of the caveats they gave us, we have to include in the equation. So some of the caveats is the fact that the second house, this is why I was writing that out and taking notes. The second house has 1,000 square feet less. So we know we're going to be subtracting, right? So now we have to look at the terms of that first house. So the second house has 1,000 square feet less than twice the square foot of the first house. So the first house, this has to be 1,000 feet less than twice. Does this so far make sense? Good. And everybody else in the live chat or actually just in the live chat, if you have any questions so far on how we set this up, this is the same thing we were doing yesterday, but now we're doing it with word problems. If there are no questions, go ahead and let me know in the live chat that there are no questions. Everybody following so far? Okay, good. So this is really more of like, this is going to be more of a reading test at this point than anything else. So we understand that it has to be 4,400 square feet and 1,000 less. So what do we use in math? And you can shout this out. Okay. So we understand that we had to be 1,000 less to get 4,400. So what do we use in math for the unknown? And if you had me last class, I know that I took over towards the end. Let me know. So what is
variable?
Okay, good. So we're gonna need a variable to fill in the place of the house that we don't know, right? Because they never actually give us the value of the house in the equation. All we know is that the second house is 2 times 1,000 less square feet, right? The second house has 1,000 square feet less than twice the square footage of the first house. So this is the equation we would want to set up. That's why I was actually very impressed looking at the live chat that just listening in, somebody had already almost set up the equation to the T. Okay. And I saw that somebody had a question. So this is the equation, and I know that everybody from here can pretty much solve this, but questions so far about how we got this equation?
No question. 2 H's for 2 houses?
Correct. Well, the H represents the second house.
Okay.
Right? So, and we want to use H because it stands for house, but we could use A, we could use any letter. Okay, somebody asked why 2H? Because in the problem, it told us that it's 2 times the square footage of the first house. That's why we're using the 2, because it's 2 times the square footage of the first house. No worries. Anybody else so far? Okay. So now that we're here, let's see if we can have a brave volunteer from the conference call. Walk us through how we would solve this so we know what the square footage of the first house is.
We need to get the variable by itself. So we need to eliminate the numbers. We're going to add the 1,000 to both sides.
Okay. So that could be one way. So I'm going to add 1,000 to both sides. And if you guys have a question, again, I try to give you guys as many ways to communicate. Send it to the live chat as we're walking through it. Let me know in the conference call. Don't be shy. Yeah. So just like we did yesterday, except again, we had to go through the word problem. The goal here, and this is no matter how many variables we have or how many operations we want to that we're working with, the goal is to get the variable on one side and the rest of the numbers on the other. Okay, so we're going to use what's known as inverse operations. I keep using these terms because that's what's going to throw you off. I would say that's like probably the third or the fourth most common thing that throws people off on the test. Inverse meaning opposite, right? So whatever they're doing here, we do the opposite to get rid of all the numbers and get the variable by itself. So now I've canceled out the 1,000. So I have 2h equals 5,400. Is that correct so far?
Yes. Yes. Is it okay? Because the
Go
way
ahead.
that I did it, the way my brain works, I didn't set that up, and it would probably help me in the future to set up equations like that and just correctly. Because what I did was I just was like, okay, there's the answer there. It says equal. So and then there's 1,000, and all we're missing is H. So
Are we missing something? Oh, and actually, I think somebody put that in the comment section. Okay, go ahead. Is there something we're missing here?
No. So I think the way that I did it, I don't know. Because I'm saying that what we had is it gives us the answer. We have like almost the answer. It's pretty easy because there's 1,000. There's just the 1,000 and then equals 4,400. So that gives us that answer. We just have to figure out
The original house, the square footage of the original house.
Yes, the original house. That's it. By just adding the because how I did it, I just added 4,400 plus the 1,000 because that's already I already have.
Except
I did it wrong.
Yeah, when we're here, when we're here, we're not done yet so far. So what I would say is that if you don't want to use the equation, see with these, even if you didn't set up an equation, you would still pretty much be working the equation one way or the other. So
yeah, but is it the right way? It's still the right way to go because sometimes some equations they don't work like that. They don't. Do you know what I mean?
Yeah, I see what you're saying. So when we look at the test, and I see that some people are kind of starting to come up. Okay, and we're going to keep talking about this. So when we look at the test, it's going to be a little different in the sense that most of it's going to be multiple choice, which is why we push the high set. The high set's probably the easiest to pass. So you're going to have that to also help you calibrate. So as you're writing down and trying to set up whether it's an equation that makes sense to you or you're literally trying to set up an equation that only works with what they provided you, a lot of your answers are going to be discriminated against at that point as you start setting up the problem. So you're going to end up coming down between two. And the advantage of that is you can take those two options and see what would make sense right back into the equation. Right? And I love the fact that people are in the live chat. So let's go ahead actually and let's set up a different equation. And I love the fact that there's so many comments. I'm still going through them. Okay. So we know that this original house, which we're going to call H, we have to add that to 2 times the value of that second house. So the second house is going to be twice as much as $1,000 less than the first house. So here's where we really want to be. There's multiple ways to solve this, but this is going to end up making the most sense.
So I have a question.
Sure.
The correct equation is 2h minus 1,000 equals 4,400.
2 plus. Because remember how in the problem it was saying that the square footage of the first house is H, and the second square footage is... So the second house is 1,000 square feet less. 1,000 square feet less than twice the amount of the first house.
I understand that, but 4,400 square feet is both house together.
Correct.
Right?
Correct. So all of this has to equal that 4,400 square feet.
I want to finish my question.
Go ahead.
So altogether it's 4,400 square feet. The first house, it means you choose variable is 8. So the first house is 8 square feet, and plus the second house is 2 times of the first house minus 1,000. Altogether equals 4,400.
Correct.
So it means the first house 8 square foot plus 8 plus 1,000. It means the second house and equals 4,400 square foot altogether.
Correct.
So the equation is 8 plus 2 8 minus 1,000 equals 4,400.
Correct.
Okay. Thank you.
Oh, you're very welcome. Does this make sense so far?
Yeah.
Okay. So this is what's going to help us determine the original square footage of the home.
Mm-hmm.
Okay. So let's go ahead and go back to the same thing we were working with before. What is the goal?
Yeah.
Anytime that we are dealing with variables and equations, what is the goal? So we have two variables. We talked about that yesterday. So the goal is to get these two variables to what?
Like H and 2H?
Correct. What's the goal here?
Multiply? I don't know.
Ooh, okay. Someone said multiply. Now, the plus sign means we're not going to be multiplying. So we can't combine them that way. Go ahead. So we know we can't multiply. How else can we get the variable on one side and all the numbers on the other? Okay. So if although this looks intimidating, we can still do the exact same thing we did before. Our goal is to get all the variables on one side, right? So what can I do with this 1,000 to get rid of it?
You could add it.
There we go. Okay. So that's going to cancel out. And what we're going to end up getting is H plus 2H equals 5,400. What can we do here to get the variable on one side, the whole number on the other? Ooh, somebody says we need to resolve the parentheses. Okay. So how do we resolve the parentheses? What can we do with this H and 2H? Can we combine those? And again, feel free to reach out using the live chat, the conference call, however you feel comfortable. What can we do to resolve the parentheses here? I love the fact that somebody said that. What can we do so that we can get this to a variable we can work with? All right. So I need you guys to speak up.
I don't know. I'm just waiting. Yeah. I don't know. I don't know. Subtract the 2.
Okay. Now it's saying that we're gonna add, right? Now, can we combine the H and the 2H?
Well, it's into their parentheses.
The parentheses is so the parentheses here is just to let you know that it's 2H. So we're doing that so we don't end up getting it confused. So it doesn't in this situation because there's nothing right next to it. We're not necessarily multiplying.
Yeah, you can't multiply with that plus sign right there, right?
Correct. So how can we combine those?
So there's always a 1 in front of the H, correct? Like an invisible 1.
There is. So what could we do now?
So we can add them, correct?
Correct. So if we did that, we would have 3H equals 5,400. Now, because I heard some silence and I heard a few people speaking up, let me know again. Is there anybody who does not understand why we were able to combine these two?
No, I haven't. So there's always an invisible 1.
Correct. So anytime you see a variable, there's always a 1 there. That's one of those things that has to be inferred. It's just like when we talk about a whole number, 5. 5 is always, for example, let's say we talk about the number 5. 5 is always over 1, and it's always to the power of 1. No matter what the whole number is here, let's say it's 7, it's always over 1 to the power of 1. Just like variables. Variables always secretly have a 1 here and to the power of 1.
Got it. Yeah. Okay.
So those are those things that are inferred that a lot of times end up getting skipped over. That's why I like to ask these questions. So even if there's like a dramatic pause, it's a good opportunity to check other math concepts. Because equations, as far as the standards are concerned, the majority of the test is going to be algebra. There are 15 math standards for functions and equations under algebra. In fact, it is the most numerous out of all of the math standards. That's why we spend so much time on functions and equations and things like that. It's the vast majority of what algebra is. And that in total will make it the vast majority of what you'll see on no matter what test you take.
So it's just mostly made up of algebra?
The test, correct. So you cannot pass the high set test or GED without the algebra portion. You can probably pass. I mean, I don't think anybody should realistically fail every part of the measurement and data, probability and statistics or geometry, but it is almost impossible. It is impossible to pass with failing algebra because on each version of it, I want to say the most conservative one is the test C, and I want to say it's like 45% of the test. But every other math standard combined is not going to like get you there, and the way they set up the points. So algebra is going to be the main focus in the math section. The way they award points, the percentages, everything. I want to say that was like, yeah, that was it. It's like everything else, you could still pass it, but the way that they gave you points for it, you wouldn't pass the overall test. So if this is making sense to you so far, you're going to be in good shape. So how do I get this to the point where, how do I get this equation to the point where I'm isolating that variable, the h? What do I need to do from here? Oh, I love it. Yeah, good. Say it all at the same time. I love it. What am I going to divide by? And what am I going to do when I divide?
By 3.
Okay, so I'm just going to divide by 3. Okay.
Combine 8 into 8.
All right, so I divide by 3. Now I'm done. What do I do when I divide by 3 on one side?
The other side, divide by 3 too.
So now I have my variable by itself. So what does my first house equal?
1,800.
Now, and I know some of you guys have taken the test. So here's the thing. If you get to this point, and this is going to probably be a multiple choice test if you're taking the high set, you can plug whatever they're telling you the house equals into the equation to see if it's true. Right? So,
yeah.
Right? So 2 times 1,800, that's 3,600, right? 3,600 plus 1,800 minus 1,000 would give you 4,400. So that's another step that you can also take. So that's when we talk about the fact that setting up the equation just helps you eliminate answers that don't make any sense. And once you set it up, you can look at what would make sense in the equation. Question so far? Because we got more.
No.
Okay, perfect. And another reason why I like to dedicate a whole day to reading and a whole day to math is that given the fact that this is a course that we're setting up now last minute, in the sense that this is not what the program is originally intended to do, be online, I really like to work through everybody's questions, right? So please, again, if you're confused on something, I pick particular problems because some of them have multiple math standards in them that are going to be on the test. So it's in your best interest. Speak up if you're confused. Even if I need to start back from the beginning or give you some stuff offline, it helps. That's why we take the entire time to work through math and the entire time to work through reading. So given the results of the first quizzes that we sent out, I think for reading, we might be able to hit multiple standards so that we can dedicate more time to math. And I'll send out a math quizzes as well in the future. Yeah, we're going to do another one. Yes, we're going to do another equation. Okay. So I'm going to write it out, and I'm going to read it as I'm writing it out so that everybody's on the same page. All right. So Julia has 24 coins in her pocket. The coins are either dimes or quarters. The total value of coins is $4.50. How many coins are dimes? All right. So who can walk us through how we're not only how we're going to set this up, but even before then, let's walk through what they're really asking us to do.
How many coins are there?
Okay, so they want to know how many coins are dimes. So she has 24 coins in her pocket, right? So we know in total we're talking about 24. Oh, I love that. People already sending out equations. Yes. Okay. So we have one equation that was submitted. All right, and I like the fact. Okay, so the unknown next to the 24. Okay. And that was actually very, very close. Okay. So we know that there are going to be 24 coins in total. right? And again, I'm writing on the problem. So if you're writing it as you're hearing it, you can do that. The coins are either dimes or quarters. Okay. So if we're going to set up an equation, how could we represent dimes? How could we represent quarters? Oh, I know you guys know how to do this because all of you guys are grown. All of you guys make money. I know you know how to represent 25 cents or 10 cents as a number we can work with in an equation. Okay, so let me put these. Okay, so we don't want to represent them as variables. We want to represent those quarters and the dimes as numbers. There's a lot of ways for us to do it. Well, we don't want to say 10 or 25 because they're not 10 wholes, right? It's 10 cents. It's 25 cents. So how can we represent that in the equation in a way that we know that we're talking about numbers that are less than a whole? There's two ways to do it. I'll give you one way. 10 cents. Another way to think of 10 cents is a tenth. Another way to think of a quarter would be 1/25th. Would we want to do that? Ooh, okay, good. I see we're starting to click. Okay, so we could use fractions. All right, now, and I see that some people are putting variables next to the quarters. Right now, we're just trying to figure out what number to use because we can write 25 as a fraction. We can write a dime as a fraction. What else could we write it as? Some of you guys are already almost solving this, man. Okay. So how else could we write it? Okay, good. A dime, decimal 10, a quarter, decimal 25. So we could represent it as a fraction. We could represent it as a decimal. I would say the vast majority of you are probably going to be comfortable representing these numbers as decimals. Right? So we have all of our pieces, right? So we know we had 24 coins in all. We have 10 cents. We have 25 cents, right? We're going to represent that as decimals, 0.25, 0.10. Oh, okay. All right. Very nice, Andre. Okay. So I like the way that you set up your equation. But I'm just trying to see here. Okay. So it's not going to be 24, but your equation is set up almost flawlessly. There's going to be a few things we're going to add, but I'm glad that we're going there. Same thing. I saw Sam set up an equation. LD. I love the fact that we're already placing these. So now that we have the pieces, we need to just look at how we need to set up the equation. I'm going to go ahead and erase it because I need the space on the board. So we know we're talking about 24, 10, and 25. Okay. And again, when you see this on the test, you will have this for probability and statistics, measurement and data, geometry, algebra, arithmetic. Always reread, take notes. So there's 24 coins in her pocket. The coins are either dimes or quarters. The total value of the coins is $4.50. So all of this has to equal $4.50. Is everybody understanding so far? Everybody understanding so far? Okay.
Yeah.
Perfect.
Yeah.
Okay. So, how many coins are dimes? So the question is, how many of these does she have? How many dimes does she have? So now we know we're going to use these. Do we need any variables? We know we're looking for the 10. Do we need any variables at this point? Okay. So I could say that this could be, I don't want to give that away. What variable would I use for dimes? What variable could I use for the quarters?
Use X for dime and Y for quarter.
Okay.
Or D and Q.
All right.
Can
So
you use any letter?
yep, you can use whatever variable you'd like, right? So we're gonna use D for dimes,
Here, if you
Q
went
for
by
quarters.
D and then Q.
Okay. All right. So we know that she has 24 of them, right? Do we know? We don't know exactly how many are dimes, how many are quarters. So what could we do here to represent that? What equation could we set up to represent that? Right, because we know that the 10, she has 10 dimes, or she has a certain number of dimes. We don't know how much they are. So I'm going to write 10 cents, unknown how many. Sorry, give myself some more space. All right, give you guys a little bit more help. We also don't know the number of quarters.
Plus 1.25Q.
Okay. Well, here we're trying to find the number of dimes, right? So the quarters is not necessarily going to be the biggest thing in play. What we really need to do is figure out like how many quarters we would have before we would need any dimes. Right? So what do I need to do with those 24 unknown coins?
Add them together.
Oh, someone said, okay, someone said add, someone said minus. Why minus? I like the idea of minusing. Why minus?
Because when we know the dime, we can minus the dime.
Correct. So we're going to minus.
Yeah.
Correct. Right? Because it's a combination of quarters and dimes, but we need to figure out how many dimes we have. So out of these 24, we need to subtract out the dimes. Does that make sense so far?
Yeah. Kind of. Not really.
Okay.
Yeah. I don't get why the dimes. Why? How do we figure?
Okay. So
How do we figure it?
we're going to be adding the dimes and we're going to be adding in the quarters. We need to figure out exactly how many dimes we have. That's why we have the variable here. Does that make sense?
Yeah, I understand that concept. I just don't know how the 24 quarters kind of implicate.
Oh, like where the 24 quarters fit into the equation?
Yeah, like why do I need to know? Well, that's where I'm not getting it. I need a little bit of help with that.
Okay, so we isolated the 24 because we needed to figure out how many out of those 24 are dimes. That's why we use the same variable.
Okay.
Right? Because
we subtract it.
correct.
You know, I mean,
yes. We're subtracting it. We're subtracting the dimes out of the 24 to figure out how many we actually have. But we don't know how many are dimes. That's why it's a variable. But we know we have to take out the dimes from the 24 total coins that we have.
okay.
Does that make sense?
Yeah.
Okay. I made this problem a little harder, but I think it was a worthwhile conversation. Some of these you will actually get on the problem, on the actual equation and the actual word problem. They're probably going to give you some of these pieces. So they're going to let you know, represent the quarters this way. But I really wanted to talk out through the idea of what functions are and what these equations are. right? So we know
I'm
that.
a little confused still.
Okay, walk me through where you're confused.
I'm confused on the dimes and the quarters are both unknown. So why do we need to figure out how many dimes, and why don't we have to figure out how many quarters?
You can work it either way because the ultimate goal is to find the quarter. The ultimate goal is to find the dimes. So the way that I set up the equation, the goal is to subtract out the dimes to see how many dimes we have. But you could set this up in a way where you're trying to figure out how many quarters you have, and then
Okay.
does that make sense? So that's the other part of. Go ahead.
Quarters for total,
What's that?
but also know the
Yeah, but also know the
24.
total.
You know how many dimes or quarters? I mean dimes and quarters you need in total, rather than just a random number to equal 450, correct?
Correct. And there's a lot of ways you can do it, right? Because I mean, you could actually have all the quarters give you 450, right?
Yeah. So it's giving you a number to see how many dimes you really need, rather than quarters.
Exactly.
Okay, I get it.
Okay. Did that make sense, Ildi?
Kinda, yeah.
Okay. No. This is important. Like,
It's still
walk us through. Go ahead. What's that?
And then it's kind of hard still to understand, but I kind of know where LD is coming from.
Okay, so this is gonna be what's.
If you explain how. Thank you, Coral.
Yeah, I love that. Hey, go ahead, break it down. Break it down, because this is an accountable talk. This studies have shown this is the best way you guys learn. So, since you understand where LD is coming from, explain to LD the way that you understand the problem.
Because I already said it, but like 24, because you need 24 dimes or quarters in total. So instead of just putting a random number saying like the 25 cents, you can make up $4.25, correct?
Correct.
But you need to figure out how many dimes you need in order to look at how many quarters. And hard to explain, but
No, go ahead.
you need to figure out how many dimes we kind of need in order to look at how many. You need to know how many total coins you need, other than just making up a number equaling 450. So you could just make 450 off the quarters. We need to figure out how many dimes you need to imply for the, or to equal the amount of 450. It's kind of hard to explain.
Okay, so what she's trying to say is that if we multiplied the quarters by the number of coins possible, that's going to help us know how many quarters we would need if we just use quarters. From that, we're then trying to minus out how many dimes would actually we could actually use, because either dimes or quarters could get us 450. Does that make sense?
Yeah.
Okay. All right. Anybody else before we start to solve it? Questions. Please ask.
Okay, so if you multiply, if you take 25 cents, there's a total of 24 coins, right? If you take the 25 cents and you multiply that by the amount of coins that we have, that comes out to $6 basically, so it's over. So, but if you have to, that means you have to subtract the amount of coins that are going to be. So it's not going to be 24 coins. You would have to. Okay, how can I make sense in this in English? I'm trying to like explain what my thought process is. If you it kind of tells you by that like how many less coins, how many coins will be left over for the rest to be. It could be dimes. You know what I mean? At all? Yeah, like it could be like 2 25 cents. Yes. Okay, exactly. Because then you're like, okay, so I have to obviously have to take away. So if you have $6 left, it makes it even more complicated to figure out. I think.
No,
If you
everything
can-
you're doing, this is called metacognition. You're thinking about your thinking. You've truly mastered something when you can either A, write about it, or B, explain it to somebody else. And that's not my opinion. Those are facts through educational studies, right? So the process that you guys are engaging in, that metacognition, this accountable talk is helpful. So keep going. Don't doubt yourself. It's all right. That's why I dedicate a whole day to math, a whole day to reading, because when you've mastered it, when you can explain it to someone, then you know that you can truly do this. And your logic is right. If we made them all quarters, we would have $6. So where do we go from there? Keep going.
Well, then it tells you that you have to. If we had, let's see, I don't know their names. Okay. So it's actually 18. So 18 points.
No, you're exactly right. You're exactly right. So if they were all quarters, we would have $6, right? And then you said that we would have,
Yeah, so it would be $6, and that isn't that's not the amount in coins. So you want to go down to $4.50. So what you do is you multiply 25 being the quarters times 18 coins instead, and
what do you think about that, LD?
450, but you don't want that. That's not. They still have to be made up of coins. Where did I just had.
No, everything you were saying was right. So the 25, if the 24 coins were made up of quarters, we would have $6, right? That's too much. So now we have that new equation now where, and this is actually going to go into solving it. So we work that out. So we have 10 dimes, or we have 10 cents. Don't know how many dimes we actually have. But we know that if all of the 24 coins were quarters, we would have $6, right? Now, we don't know how many dimes we have. So we're going to multiply. Okay, go ahead.
Okay, so I got back to
Yeah.
So yeah, then the 24 coins. What I did is I minus the 18 coins that I had to use to multiply with the 25 quarters. You know what I mean? So I minus so if you go, that leaves 6 coins left over. That's going to be the dime. So and then okay, I'm gonna let you continue. I'm gonna be quiet now.
No. That was very helpful. So everybody understands how we got here. Now, so remember, so now we know how many would be quarters, right? So we're also gonna end up, but we need to take that away. We need to take away what the dimes would be. Except here, we're gonna multiply by 25 so that we can start to see what the maximum number of quarters are, right? So now that we're here, we know that we would have a max of if all of them are quarters, we'd have a max of $6. We can't do that. We need to figure out what the maximum number of quarters are to get the dimes, right? So we're going to multiply that by the unknown, right? So we're going to have subtracted by 25. My marker's dying. 25D.
25D. So we subtract the 10 cents to the 25.
And why would we do that? You're exactly right. And somebody else was speaking. Everybody's speaking. I love it. Why would we do that?
The combined.
Yes, we need to combine like terms because the goal is always to get the variable by itself. So we can combine these, right? So 10 plus negative 25 is going to give me what?
Negative 15.
So we have negative 15D.
Okay. Oh yeah.
Does that make sense so far?
That's a point 15. Is
0. Yes.
Point 15.
Point 15, yes.
Not 15. 0.15.
Correct, because we have 10, we had decimal 10,
Yeah.
decimal 25, right? Now what?
Yeah, decimal 25.
Okay, so now what do we do?
So you still have the number. From?
Ooh, two people speaking. All right, who wants to go first? Go ahead, Sam.
Okay, I can go.
Go ahead.
So now we get negative 115D plus 6 equals 4.50.
All
6.
correct. All we did, we brought down all of the other terms, right? So we isolated that. So because we combined them, we had negative 15 cents, negative 15, don't know how many dimes. We brought down our 6 equals 450. Right. So now we're getting closer to determining the number of dimes.
Yeah, and then subtract 6 from both sides.
Okay. I'm going to do it in a different color so that it's easier to see. And what's that going to leave us with?
Come from?
That was the highest number. That's what would happen if they were all quarters. That's where the 6 came from. We need to get rid of that, though. We're basically working backwards. We know that if they were all quarters, it would be $6, right? So now we're trying to see what is the maximum number of quarters that can exist so we can also have dimes. That's exactly what we're doing.
Yep.
Right? So that's what we got to this equation. That's why we're subtracting out the $6 because that's over what we want. Does that make sense?
Yeah.
So now what?
I don't think I would be able to solve this by myself. This is
and that's all right.
Difficult for me.
And that's all right. That's why we're doing it in the beginning. Everything that we're going to cover first is what statistically, according to the tape test, according to the quizzes that you take, my conversations with Michael, and my experience, we always will cover the hardest things first. So we have the entire time to work through those standards. That's why everything that we do is based off of the math standards. So we cover the most difficult math standards first. We dedicate as much time as we can to it. So if we have to do 2-3 days of equation word problems, we can do that. And if we run out of time to cover other standards, those other standards that we're not covering, statistically, you guys have had strength in those standards. Does that make sense? Yeah, that's why we don't do like geometry and arithmetic first and all that stuff, because if we had to forgo something. Go ahead.
8 dimes. 8 dimes and
okay.
quarters.
Okay, so let's see. So $4.50 subtracted by 6. What's that going to give us?
450 subtract
Mm-hmm.
negative 1.5.
Negative 150.
Oh, no.
You're exactly right. Negative 150. So now we have, I'm going to rewrite this. Sorry, I'm running out of space. So I'm going to rewrite this a little higher so everybody can see. So negative 15 cents D equals negative 150.
Decimal 15 D equal negative 150. So
negative and negative becomes positive.
Correct. So we're going to divide by negative 15.
B equals
Oh.
1.50. 150. Yeah.
So how many dimes do we have?
Yeah. 10. 10.
And 10 dimes is what?
10 dimes is $1.
And then everything else can be quarters.
Yeah, 14 quarters.
Yeah. So this is also another reason why, as we do reading, well, to give you kind of a bigger picture. So we also get money from other programs, and some of those other programs require us to talk about computers and workplace skills. And a lot of other teachers don't like to do that, or instructors. I like to do it because one of the things that makes these word problems difficult is the background knowledge, right? Most people are going to have background knowledge on money, but that's not always the case with every problem. So that's another reason why I encourage everybody else to talk, because if it starts becoming something outside of math or reading, there can be value in that, right? So in this problem, I would say everybody has handled money, but the previous problem with the houses could be a little confusing. And we have plenty of time and plenty more examples to go through. So judging by how we work through this in the chat, oh, sorry, I'm looking at the comment. We are looking for. This is why it's. Yes. Good job. Yes. Okay. Sorry. Somebody had a comment before we move on to the next problem.
I'm Lydia, by the way. Probably won't. Hopefully, you recognize my voice later throughout this whole thing, but. I have been commenting so much. I just have so many questions. This is the way I figure out answers. Like these answers here is not with the equation that's in front of me, but in like my own way. And if I still get to the answer, is that okay, or is that because I know, like I said, like I referred to the other equation, but I know sometimes that in itself can might not.
Yeah, may not always work. So here are a couple things you can do. So all the problems that we do and the things that we use in this course are going to be more difficult than the actual test. Like for example, on Aztec, if you're getting a 40% on a problem, you would pass that in the actual HiSET GED test. Again, not my opinion, facts. Those are data. That's data that's pulled by our IT department and several other people. So
But they put this thing harder so we can
correct.
easily.
Correct. So like if you're blowing it, you're like, oh man, I got 60% in Aztec in algebraic equations or slope intercept form or whatever, you're actually going to do very well in the test. So and
take that test. I don't know.
Yeah, because remember, like, so our program is only funded by how many of you guys are passing. We have different, obviously, components with like English language learners and all that other stuff. I say that because in this problem, for example, there is no multiple choice. I didn't give you a hint about how to represent the quarters. You would get that on the actual test. The vast majority of your questions are going to be multiple choice for the math portion.
Will we have to form an equation?
They may ask you which equation would solve the problem, but even if they did that, all you'd have to do is plug in the numbers from the equation in the multiple choice options and see which one makes sense.
Okay. Yeah, because that's me putting the equation together.
Yeah. So if you were working this out on your own, you'd have the advantage that they're gonna tell you how to represent a lot of these. They're gonna say, hey, if they're quarters, please represent them as decimal point 25Q. So they're gonna give you more pieces than what I'm giving you. So this is going to be harder than what you would get. And you'd have the multiple choice options. So then you could look at, well, I know this equation is not going to make any sense. And you can narrow it down that way.
Yeah.
So yes, what I'm giving you is much more rigorous than what you're going to see.
Okay.
Ready for another one?
Oh. Yes.
All right. So,
Yes.
yes, just had my cold brew from Dutch Brothers, so I'm even more hyped up now than normal. Okay,
Is that your one?
my a cold brew coffee from Dutch Brothers.
Oh, yes. Kidding.
Yeah. All right. So this was going to be a short one, and I'm glad that they're sticking to things that we have background knowledge in. Okay. So the Bulldogs won twice as many games as they lost. I'm going to write that. Bulldogs won twice as many games as they lost. Okay, so as we're writing this, what should be coming to mind when we think about variables in these equations? What should we start writing down? There we go, 2x, because they won twice as many games as they lost.
Right?
Yeah,
I got that right? Oh,
yeah, because we don't know how many games they played. All we know is that they won twice as many games as they lost. So 2x is a way for us to think about those variables. And this is what I mean when you're testing. If you didn't see 2x in one of the possible answers, then you know that answer is wrong because it needs to be 2 times something. We don't know how many games they played. We just know they won twice as many as they lost. So we need to multiply 2 by whatever amount of games they had. Make sense? So this is where we start to kind of piece things together as we read. If they played a total of 36 games, so what is that going to tell us? They played a total of 36 games.
Equals 36.
See, there we go. And I would write that out. Equals 36. Why? Because they played 36 total games. This doesn't mean that these will show up exactly like that in the equation. But again, we're doing that metacognition, right? We're thinking about our thinking. So we know it's going to be it's going to be 2 times whatever, right? They won twice as many games as they lost. But they had a total of 36 games. On the test, I'm going to use that information to discriminate against my possible answers, right? Process of elimination. How many did they win? And they're going to give you a little bit more information. No games, and they're going to tie. No tied games.
It will be half of 36. Am I wrong?
Ooh, okay. Why would you say half? Let's set it up as an equation. Go ahead.
They have a total of 36 games, so equally they each lost and won. So it'll be half of the games they won, half of that they lost.
Ooh, okay. Yes, we're getting on the right track.
Okay.
All right, so let's go ahead and try to set up an equation. And again, like we talked about before, you know you're going to have additional tools when you're testing. You're going to have multiple choice, etc. Right? In fact, I want to say most of these companies are going to move to just testing online. Like the GED's only online because it's cheaper. If not, you have to pay somebody like me to grade it, and they don't want to do that. And I just say that because it's easier for it to be multiple choice. So that's probably going to become the standard. So let's think about how we can set up a problem. So we know everything has to equal 36. And I'm sorry, it was this there's some people that were talking before. Who said that they had to win about half their games?
Me, Cora.
Carl, okay. All right. So we don't know how many games they won. So what variable could we use to represent that? We know everything has to be 36. What variable could we use to represent the games or the wins? What's that? G? Okay.
G for game.
All right, I like that. Okay. So how could I set this up? And why did somebody, I think it was Sam or Lydia, I don't know exactly who it was,
Yeah.
had mentioned half. Why half? Where did we get the half from?
No, I think it's games in one half.
What's that?
Because they played 36 games in one half.
Ooh, okay. So half of the games.
Do we ever set up an equation with a division?
You could, just depending on what they ask you to do. Right? Because so you're not going to have the word problems will exist for every domain of math. I don't know if I don't think I've ever explained that. I don't know if anyone else has ever explained that, but under math, there's going to be different domains, right? So you have geometry is a domain, algebra is a domain, measurement and data is a domain, probability and statistics is a domain, and so is arithmetic. You're going to have word problems in each section. Although the arithmetic word problems, you're going to have division, but they're going to be pretty simple.
Can we convert them into decimal?
What's that?
If it's if I'm sorry.
Go ahead.
Like if you have a fraction, can we convert it to decimal?
Correct.
If we wanted to.
Yes, that's numeracy. So when you're able to do that, that's numeracy. It's just like literacy is your ability to read. Numeracy is your ability to comprehend numbers. So if you look at 1/25th and you know that that's the same thing as 25/100ths or a quarter, or you look at like 9/12ths and you know that's really 3/4ths, all of that is fine, because if that number becomes friendlier to you when you change it to a decimal or a fraction, you're still going to get the same answer. But that shows a high level of numeracy because you're manipulating the numbers. So yes, you can always do that.
A lot easier when it's a decimal rather than
Yeah, I think that's actually something that Ildi said as well, that she's more comfortable with the decimals than the fractions. Yeah. So that's all part of numeracy. You can always manipulate the numbers, and this is why I like us to have these accountable conversations with each other. And I don't like assigning things that are just self-correcting all the time, because it's this accountable talk where you see that these things are permissible, right? Like if I wanted to make this 0.5, I could. Is 0.5 the same thing as half? Yes. However you see the problem, however you feel more comfortable, that's really like on an individual basis, right? And for me, and I've seen that the more tools you have, the more you can work it. So then you can kind of pick and choose, like, oh, well, this might be better as a decimal, this might be better as a negative number, etc. So we don't know the number of games that they had, but we know they had to win half. So going back to that, why do we know they had to have won half their games? Ooh, where'd you get 18 from?
So what I did was just figured out what two games, like dividing the 36 and by two, and then
So you divided the
it gives me
36?
18, and then you add 18 plus 18, that makes 36, and it says the Bulldogs won twice as many games as they lost. How many did they win? So yeah, I came out to 18.
Okay, so that's what you think the answer is?
I don't know.
Okay, all right. So I like where your head was going before that. Okay, so we know that the reason we have half here is that if they have to win twice as many, we have to cut it in half, right? So if they played 36 total games, we know that half of those is as high as what 2 times can be. Does that make sense?
Yeah.
So we need to look at the total number of games plus the half of the games that they had won. So we're really setting this equation up here. And then we're gonna, this is gonna be a little bit of fluency here. Now we're gonna go back to equations and functions and isolating the variable and inverse operations. So we set this up. We know that half of the games are the most that they could are pretty much the number we would need to know so that they're winning twice as many games, right? And now we're looking at how many games they actually won. So how would I go about solving this?
So would you have to divide across?
Multiply.
We can start in a couple of different places. You guys tell me.
Or can you add the functions together with suppose that G and G? I'm not sure. We work on denominator.
Okay, so and this is what I know that a lot of times we break down, and I see in the live chat that some of you guys are using algebraic thinking. You're just like plugging in numbers that you know would make it true, and that's good. When we start getting multiple variables and multiple operations, always stick to that time true tested system of getting the letters or the variable by itself. We need to get rid of everything else so we have the variable G on one side and the numbers on the other. So what's the first thing I can get rid of?
We can add these two. We can add them together, no? The denominator.
The denominator? Okay, so what should I do here? What should I do to get rid of this?
You can add the two G's together. Make it two. Make it a whole.
Woo, okay. So somebody said we could add the G's together. We could. So somebody said we can add the G's together. So let's say we did that. Let's say we're like, hey, we have two of the same variables. Let's get them together. How would we do that? G plus half a G. What would that give us?
Well, I converted it into a decimal.
It would give us a whole, right?
Oh, I love this. Okay. So whoever converts to a decimal, we're going to do the fraction first. Then I would like you to explain to the class how you converted it to a decimal and what you did. So first, this is great, by the way. It's like what teachers dream of. So let's start off with keeping it as a fraction. That's going to be our first method. Ildi had mentioned combining the G's because they're the same thing. So let's make it simple. So how would we combine these G's?
Putting it together.
All right. How do we do that? What is it going to give us?
So it's gonna be
So it's always
1.5. 1G plus half G is 1.5G.
Or 1.5 G. Okay. All right. So we're there.
Or
Now-
1,
Yeah. Okay. What about if it was a decimal? Right. So this is as a fraction. Go ahead.
1.5.
1.5 for 1.50.
So we could have 1.5. We could have a half.
Mm-hmm.
1 whole and a half. It's the same thing. The only difference is whatever makes you feel more comfortable. So we can work with both. So now that we agree it's going to be 1.5 G, we got rid of all of this. What's the next step?
Divide across.
Divide across. Oh man, that's hard.
No.
Actually, no, you could divide across.
Well, I converted it into decimal, so I guess it would be harder with a fraction, but since I converted to a decimal, I divided across.
And this is the other part of the equation. There are multiple things I could do here. What I would recommend, because this test is hours long, whatever method you use, stick with it. And what I mean by that is if you always change it to a decimal, do that. If you like a fraction, do that. If you're comfortable leaving it as a fraction and multiplying it? What's that?
That's what I was going to mention as well, is that there's different ways of
Yes.
what's the easiest for you is what do you go with? Yeah.
Yep. That's numeracy. Yep, that's that numeracy. You know how to change the numbers. Okay, so here the question is, and we're going to solve this multiple ways. So we got through the problem fairly easy. Now we're going back to basically fluency, working these operations. So who would like to solve this just keeping it as a mixed number? Not a decimal, not an improper fraction, just a mixed number. Who could tell us how to solve this?
I'll say with the decimal.
Okay, you want to change it to a decimal? Go ahead. Walk us through how we would solve it.
I would put 1.5g equals 36.
And now what?
And then I'm going to divide both sides by 1.5 and g equals 24.
All right. So this is if we were to use. So g equals what? So this would be if we were to use. Huh? Go ahead.
Yeah. So the question was, they won twice as many games as they lost. So they won 24 games and they lost 12.
Okay. So that would be if we kept it as I'm sorry, if we use it as a decimal. What if we don't like decimals and we wanted to keep it as a mixed number? It's 1.5. How can we solve it that way?
That I don't know.
Okay, so I'm going to bring this to the other side. That's going to be 36. Now, we're going to divide, right, by 1/2. So we can get the g by itself. So it's going to be 36 times 1 and 1/2. Now, we multiply, I'm sorry, divided by. My fault. When we're dividing fractions, I can teach you how to do an area model, but that's not going to be helpful. Understand, we can do an inverse operation here. What is the opposite of dividing? Multiplying, right? So I can change this into a multiplication problem as long as I flip this around, right? And there's a couple of things that I can do here. So you might go, wait a second, how do we flip a mixed number? By making it into an improper fraction. How do we make this into an improper fraction? Couple of ways. You can take the denominator, multiply it by your whole number, add it to your numerator. 2 times 1 is 2 plus 1 is 3. So this is actually 3/2.
That's 3.
Yeah. If you have a lot of time and you're like having trouble sleeping, you can break it down into models. 1 whole and 1/2. Right? And then you can combine and you would end up seeing that you end up with 3/2, right? So if I brought all of these over, you would end up having the 3 over the 2, right? I don't recommend the models, and I actually shouldn't even have talked about the models because that's not going to be the most efficient method. When we want to convert a mixed number like 1.5 to an improper fraction, I'm going to give you an algorithm, okay? If you have kids at home, because I also teach 5th grade and 6th grade and taught every grade level, what I'm showing you, Go ahead. No, that's okay.
Can we do we'll do another one of these, but not in any just not as fractions or decimals? Is that possible? Like,
Yeah, I could find another word problem that would have whole numbers or anything like that. Decimals and fractions is probably going to be the way they're going to try to trick you.
uh,
Yeah, this is like pretty much
okay,
like,
never mind. Stick to what you're doing. I might just need another.
yeah, we're going to definitely do more. We're going to definitely do more problems. So we'll definitely get more
I got
opportunity.
I got the previous question. I figured that one out. It's just this one. I'm like,
Are you confused on how we set it up, or are you confused on this operation here when we're multiplying whole numbers and fractions?
yeah.
Okay.
That one's always been my issue. Anything with fractions, I'm always
I guarantee you, I will make you an expert in fractions by the time I'm done being your instructor. I'm going to give you so many different ways to look at fractions. So I'm going to give you the algorithm. This is like memorizing steps. A lot of times your teachers don't like younger grades to do this, but for the test and passing, it's great. A fraction is a piece of a number, right? So I'll give you a model after. But when we're talking about wholes and then pieces, if you want to convert it to an improper fraction, take your numerator, take your denominator, multiply by the whole number, add it to your numerator. So we're going to multiply the 2 by the 1, that's 2. We're going to add that to our numerator, which is 1. That's 3 halves. Does that make sense?
yes.
And those are just steps you're going to memorize. That's not, I can show you a model after this so you can see what exactly I mean by the whole and the half and when we're combining them. Okay. So now that I know it's 3 halves, I can now flip it because I know that it was supposed to be division, but I'm going to use a little math trick. I know that multiplying is the opposite of dividing, so I can now change it to a multiplication problem and just flip my fraction, and I'll get the same answer. So I'm going to flip this. The math term for flipping is the reciprocal. So now this is going to convert into 36. And what? Oh, this isn't a fraction, is it? How do I make that into a fraction? What do I have to do?
Add a 1 at the bottom.
There you go. Put it over 1. Okay, so multiplied by 3 over 2. How do I multiply fractions?
Cross.
Mm-hmm.
Multiplication.
So 36 times 3 is what?
72. Or times 3? Oh, okay.
Mm-hmm. Times 3.
Okay. 108.
108. That divided by 2 gives you what?
And then you divide it, you said?
Correct.
4.
Oh, I'm sorry. I ended up skipping a step. Okay. We never flip this. We need to flip this. Sorry. Yeah, sorry. That was my fault. Okay. We did not flip. So 36 times 2 is what? You still multiply across.
72. 36 times 2, 72.
And that divided by 3
Yeah.
is what?
24.
So that's how we would do it if we were to keep it as a fraction. Now, I know one person admitted they struggle with fractions. I would love to make this into a fraction mini lesson if we can, but I want to make sure that there's other people who have questions about the fractions. Does anybody else? And you can answer in the live chat as well. I can talk about, because this is going to be common. You're going to see this in algebra. You'll see this in arithmetic. There's going to be a section by itself. So although algebra is the most, like the biggest component of the test, no matter how, even if it's 45, they're not going to give you credit in the other sections in a way that's going to help you pass. Fractions is going to be present in every domain: geometry, arithmetic, probability statistics, the whole nine. So if we would benefit from talking about fractions, I can do that real quick before we move on to the next problem, because we have plenty of time. If you would like to do that, go ahead and send me a message. Speak up in the live chat. Speak up in the conference call.
If I want to, I'm just joining your class now. I'm Lydia. So I'm the one that said I struggle with fractions. I've always struggled with fractions. And if anything else that I have, I just send you questions and everything. Because I'm not sure how long this class. It started on Monday, right?
Correct.
Yeah, so it started on Monday, and I wasn't in these classes because I didn't receive any text or email or anything. So they had me in the system, but they didn't put me in the class. There was like some issues. So
Yeah.
I need to catch up a little bit. It's good I'm not too far behind you guys Thursday now. But if I have any the areas that I'm weak in, I can let you know, and then you can tell me if we're going to be covering that. Because I know with the test that I took, the areas where I'm not good at. So that is fractions.
Yeah.
Fractions.
So you know what? Let's. Yeah. You know what? Let's do a quick, because I guarantee you that like within 5-10 minutes I can help you understand fractions. Okay. So when you look at fractions, what do you understand fractions to be?
I understand fractions to be.
Okay.
But there is.
All right. So let's start off here, right? So let's look at that number 1.5, right? So let's use an area model, a model. So the denominator lets us know how many pieces we need to get a whole. So because it's 2, that means that to get a whole, I need to fulfill 2 pieces. Does that make sense?
Yeah.
So let's just look at the half, right? So I have 2 pieces that I need to get a whole. My numerator tells me how many pieces I actually have. So here I have 1. This would be a half. Does that make sense? Okay. Now, let's say I have 3 halves. I'm still going to use the same concept of the model, right? So that means that I have 2 pieces here, right? And these are full. I like to think of them almost as like buses. So, or maybe like a box, right? So there's a box that can fit only 2 shoes, but I have 3. So what does that mean? I have one box that's full of 2 shoes, and I have another box that only has half of it filled, only has 1 shoe. So I have 1 whole and 1 half. Does that make sense?
Yeah.
So let's look at 5. Nah, make it even bigger. Let's look at like 12 fifths. This is an improper fraction because now my denominator is greater than my numerator is greater than my denominator, right? Improper fraction. Sometimes we want to leave it as an improper fraction because like in the last problem, that made it easier for us to multiply, right? Sometimes it might be better as a mixed number because the problem is calling for it, right? So if we looked at 12 fifths, and I'm going to rewrite this in a bigger and a much more spacious area. Okay. So if you look at 12 fifths, right? how would I rewrite this now into a mixed number? And anybody can do this. You want to answer in the live chat, conference, anybody can answer.
Divide the bottom into the top.
Okay, that's one way. So I could say, how many times does 5 go into 12, right? Well, 5 times 2 gives me 10. I have 2 left over, right? So it can go in there 2 whole times, right, with 2 left over. And you notice that the method we talked about before still works. 5 times 2 is 10, plus 2 is 12, 12 fifths. So that's one way. Now let's think about it as an example, right? And this is going to be mostly for Lydia. So give me an example of how you know that it would be 2 wholes and 2 fifths. You could think of buses, you could think of boxes, containers.
Give you an example.
Yeah.
Just like how to previously.
Yeah.
Oh, you mean like as a word example.
Yeah. Let's say you have a car that can only hold 5 people, but you have 12 people that need to go somewhere. How many cars are you going to need?
I have 12 people, so then they're going to need 3 cars.
Okay, so let's look at like how full the cars would be.
2 cars full.
Yes, 2 cars are going to be full.
5
Go ahead.
can be full, and then the other car is going to be 2/3.
Or yeah, so 2 are going to fit, and then that's out of the 5 possible spaces, right?
Yes.
Now you understand fractions.
Oh, 2/5. I put 2/3, but yes.
Yeah, because 2 could fit out of that possible 5 spaces.
Mm-hmm. Yes, the 2 being the whole number, and then the 2/5. That the 2/5 is out of the other car, fit in the other car. Got it.
Make sense? So now does this also help? Does this also help it make sense that when we talk about a whole number like 35, does it help make sense why 35 is over 1? Because you have. Go ahead.
Well, it's because it's the larger number, and the larger number is on.
Well, think about it this way.
Top.
Think about it this way.
Is it the denominator? Okay.
Think about it this way, right? Same example. So 1 car can take 1 person, and I have 35 people. How many cars do I need?
35.
So you have 35 holes.
Yeah. Okay.
Does that make sense?
Yeah.
And that's pretty much everything you need to know about fractions.
Okay.
So as long as you know that the denominator is the pieces you need to get a whole, and the numerator is whatever they're giving you, then you'll be in good shape. Now, as far as multiplying and adding fractions, I'll give you a quick thing before we move on to the next word problem. You're not going to be doing anything outside of adding and subtracting fractions. Okay. Now, would you like me to give you a model or a quick, like, standard algorithm, like a quick set of steps that you can use?
Your second option.
Okay.
Is that?
So let's say we're talking about a half, adding it to 2/3. Nice small numbers. Okay. Anytime you get into the situation, you can use what's known as a butterfly method. And this is like a series of steps we just follow. We always multiply the denominators together. That's going to give us our new denominator. So our new denominator here is going to be 6. This is straight memorization. There's not a lot of numeracy, math logic, none of that. That's going to give me my new denominator. Then I'm going to take my denominator, I'm going to multiply by the numerator on the other side. That's going to give me my new numerator for my first problem. Do the same thing on the other side. Now that they're out of the same number of pieces, I can add them together. Does that make sense?
Yes.
Okay. Same concept when we're subtracting. Now, multiplying, I'm sure you know we go straight across. For dividing, whenever they give you a fraction, all you have to do is do the reciprocal. Flip this fraction and continue to multiply. If they give you a whole number, right? Let's say you're talking about a whole number. If we have 5 plus 3/4, what would you have? 5 wholes, 3/4. Right? Pretty straightforward. When we're subtracting, just think about the number of wholes. Let's say we have a crazy number, 5 minus 22/40. Humongous number you're never going to see in the test, but it shows my example. Well, how many pieces do we need to get a whole? This is for Lydia.
1. 4.
How many?
Don't you have to make the 5 into a fraction?
You can. 5 over 1, sure. But we're looking here, right? Because this is a whole number. So we know we have 5 whole pieces,
whole
right?
number.
This fraction,
Number.
how many pieces do we need to get a whole?
Show me, please.
So you see the numerator here, the denominator here? That's how many pieces we need for a whole.
40.
Correct. So every time we get 40 pieces, we have one whole, right?
Okay, yes.
How many pieces are we missing to get a whole?
Moment. The 18.
Yeah. So if we added 18 pieces, we would get another whole, right? So that would give us one whole. But we need to get all the way to 5 wholes. So to get to 5 wholes, I would still need 4 more pieces. Does that make sense?
Yeah.
So how many pieces would I need altogether?
Mm, 418 over 40 is the answer.
Yep. And Lydia, so do you understand where we got the 4 from?
No.
Okay. So you see how you said 18 over 40 is what we needed to add
Yeah.
to this to get a whole, right?
Mhm.
So we know that has to be part of the answer. We need at least 18/40ths to get us one whole, right?
Yeah.
But how many wholes are we looking for in total?
5.
So how many
Five.
more holes do we need?
4 more.
And that's why your answer is 4 and 18/40ths.
Oh, okay, got it. Got it.
Does that make
All right.
sense? Okay, so I'm gonna throw a quick one up here. Okay, so 3, and then the last one, then we'll move on. Okay, so let's say 3, and I won't make the numbers as crazy this time. 5/20ths. What would my answer be?
Okay, so there's three holes, and so let's see. So 15.
15.
That's 15. Is it 15 over 20? Or do you?
Yep. And what else?
That's 15 over 20. And then the number is going to be 2.
You are now a master at fractions.
Yes?
Yeah.
Oh, yes.
Yeah, I'm telling you, you got it. That's it. That's it. That's all. That's really all there is. If they ask you to divide fractions, you know how to make a whole number into a fraction. You're now an expert.
I'm doubting myself there. Too much doubting.
That's all right. That's all right. That happens a lot. I know that there's a lot of like testing phobia and anxiety, but you're going to do well. Everyone in here has done well and will do well.
I have a question.
Yes.
So when we have it kind of like for the fractions, when we simplify, is it always like do we have to simplify the answer or do we have to keep it the answer?
Ooh, great question. So, couple of things. Okay. So if we have a fraction, let's just say like 5/25, right? If they want us to simplify, then we need to. Sometimes it might be easier to simplify it, even if they don't ask us to. I can send you guys out a quick video of all the rules for greatest common factor. Okay. Greatest common factor is going to be more like numbers and operations. And that's another like math domain. But there's a couple of rules. So I'll give you some quick hits because I'm sure like here, everyone knows that 5 can go into 25, right? So I'm going to divide by 5 on the top and on the bottom, that's going to give me 1/5. But there's rules for other numbers too. If the number is even, it can be divided by 2, right? We talked about this a little bit yesterday. If I can add up all of the numbers together, right? 4 plus 2 is 6 plus 3 is 9. If I can add all of these together and the answer, the sum, can be divided by 3, which it can, then this whole number can be divided by 3. That's another rule, right? Go in there, right? Bring down the 4, right? Etc. Right? So that's something to consider. So you have rules for 2. You have rules for 3. 4 is going to be similar. It's like 4. If you add up all the numbers, you can divide it by 4. If you want to look at 5s, if it ends at 0 and a 5, there's rules for everything. I think the only one I couldn't find a rule for was like the number 9. But I'll send that video out. So that's an easy way to know how to simplify. If they ask you to simplify your answer, you have to.
Well, what if it's okay? So what if there's a question, because I've had this before, where it's the simplified answer and a non-simplified answer. So do I always have to choose the simplified answer?
No, if they don't make you simplify, what's that? Go ahead.
No, yeah, go ahead.
Oh yeah, if they don't make you simplify the answer, you don't have to. Just to give you a little bit of, go ahead.
What if it's not the question where it's the simplified answer?
don't see you getting that too often. Does that make sense?
Okay, yeah, because I got a wrong answer right now. Well, simplifying it. So
Yeah.
I'm choosing the simplified answer rather than the answer that I thought.
Yeah, so if you got 5/25ths and then you're like, wait a second, no, there's no answer that's 5/25ths, then you know they're asking you to simplify. If you simplify 5/25ths or you simplify your answer and it's still none of the multiple choice options, then you're wrong.
Okay.
Yeah, because and before we move on, I just want to throw this in here because one of the things that I think people forget is that with these companies is that they're companies. They want to make money. So their goal is to be as profitable as possible with these tests. They're going, I would say most of them are probably going to start going to just being computer-based only because it's cheaper. So if you were to put in 5/25ths, the computer they use is going to know that's equivalent to 1/5. I can build a program that does that. I'm very comfortable with technology. So you're going to see more of that. So those tricks that you're worried about shouldn't come up too often.
Okay.
Yeah, you're very welcome. All right. So let's keep going. The sum of 4 consecutive even numbers is 212. I'm going to write it in blue because my black is fading.
I have a question.
Go ahead.
Not regarding exactly this, but I've been thinking. I know we have 5 subjects to test on.
Correct.
Is there a time frame? Do we have a time that is given when we need to finish the 5 tests? I know that we can take the tests separately on different dates, but if I take writing and reading tomorrow, is there a given time that I need to finish the other 3 subjects?
So as far as like, it's like if you did like the social studies portion, do you have to finish it within like a month? You have to finish the other portions in like a month or a day or whatever. That's determined by tests. I actually have a graphic I can email you guys that lets you know the particulars, but the only one that I think is stringent on like making you finish within a certain amount of time is like the GED. But last time I looked, actually the last time we did it together, the high set and the task C gives you a long time. I want to say that the high set, you can like almost it like the other sections that you don't test on, like almost never expire. I'll look at that again because I don't want to misinform you, but it is a long time I know for the high set. So if you like pass the math portion, there's a really long time that still counts. So you can take the reading and the writing and the social studies and the science.
Maybe like 3 months.
Something like that.
Maybe if somebody needs additional studying in one subject, so we can take a little time and maybe
Correct.
take another class. Okay.
Yeah.
Okay, thank you.
Yeah, and I have had students do that. You're welcome. In fact, I think the last time I taught reading before this whole thing happened, out of all the students that I had, 10 of them, one of them was the last time I taught reading out of that class, I had one student return and they had passed everything in reading and they were just there to take the math. So you can definitely do that. That's actually why I'm doing the reading and the math now. But yeah.
So if we wanted to, we can just come here for the reading part, and then when school starts again, can we maybe take math because maybe we learn better?
Yes.
Classroom already. Is
Yes.
that possible?
Yes, absolutely. The only
I was going to ask that too. If you are going to be teaching, I don't know if you know when things are going to
that is
somewhat normal.
That's the hard part.
Yeah, that's the hard part is to determine.
Yeah, because
because that's more like for me, because that's what I'm concerned mostly as that's how I learn best is actually in a classroom.
Yeah.
setting. If I'm going physically to a classroom and
yeah, in fact,
how
our
I
grant,
have learned.
the money that funds us isn't even really allocated for online classes, but due to the current situation, they made an exception. but usually these classes are going to be in person. What I would recommend is that you take whatever section you're comfortable with. I think, judging by your scores and the amount of participation, I would say the vast majority of you guys are ready to test. I don't like the practice test in that if you do well, ultimately you're still not passing. But the high set, if you pass their practice test, they give you a certificate to pay for the actual test. I'm not sure when the testing centers will be open. I know Mike does know that, and he's like keeping track of that. But I would recommend that you test in the actual tests, no matter who opens up first, TASC, GED, so that you can start knocking those subjects out. The student that I had the last time I taught in the classroom, the only thing she needed was the math. I was her reading and writing teacher. She had passed that. So,
But being honest, I'm struggling. I'm struggling to keep up and with the math. I just, it's hard for me personally to learn like online, and
I agree.
yeah, I'm struggling.
I agree, because also everything every teacher uses is what we feel comfortable with and how we want to roll, because there's limits to what the program can give students to learn. So I would recommend, because I don't know when things are going to come back to normal, that after this class that you test. I've had students that pass and then go, I don't know how I passed. It was a miracle. There's a lot of self-doubt, but they passed. And yeah, there's a lot of self-doubt, but you shouldn't have any doubt. But
Personally, I want to take all the tests
yes,
except for math, because I know math.
do it all. Do it all. I'm telling you.
Everything else, I feel like I have a good chance.
Do it all. Do it all, because you can pass. You can pass. I'm telling you, you can pass. Like,
and when you take the test, if you don't pass the math, you take the test again. Is it a completely different test?
yes, but the math concepts are still the same. It is, but the math concepts are still the same. So instead of saying the sum of 4 consecutive even numbers, you're going to get the sum of 3 consecutive even numbers. Does that make sense?
Oh, yeah.
The domains are still the same. All of that is still the same. So I would recommend testing. Test, because we don't know when we're going to go back to a physical classroom. And to be honest with you, I don't see it being anytime soon. I'm also a teacher in the school district. We don't even know when we're coming back.
Yeah.
I think Mike mentioned that they're looking to open up the testing center July 1st.
That would be great.
We had the Zoom meeting last week.
Yep.
So,
And like I said, I'd recommend doing it.
I already scheduled a test in June. My test in June. So
There you go. Yeah, and like I said, I'd recommend testing. Not to brag, but I'm rated top 10% of teachers in Nevada. Both
brag, man.
top 10% of teachers. I've gotten 2 awards from Congress, and teaching has helped me get now almost like 5 houses. I'm working on closing on my 5th home. I'm good at this. Like, you will do well. Like, if you, I'm telling you now, like, my credentials speak for themselves. My 5th graders have higher. When I taught 5th grade, we had higher proficiency than every other 5th grade teacher combined, and then some. Students grew over 1,000%, and the reading department that I ran for 6th grade had higher than 7th grade and 8th grade together. Like, you will do well with this, guarantee it. So test, you'll surprise yourself. So yeah.
I have a test. You can schedule taking your test. You guys, if you're interested in taking your test. Mine is June 2nd. They have times throughout the entire month of June and then July.
Do it.
And it's at the Cheyenne Avenue campus.
Do it.
On the Cheyenne campus. So.
Yeah.
And you did that online?
Yeah. Did it online. Awesome.
Yeah.
Find it.
Perfect. All right, so let's finish this up here. We got about 16 minutes. Okay, so the sum of 4 consecutive even numbers is 212. What is the third number? Okay, so there's a couple things we're going to do, and they gave us a hint. And this is something that you will probably get on the test. Let x equal the first number, x plus 2 the second number, and x plus 4 the third number, and so on and so forth. So before we even use that, let's really break down what they're asking us. The sum. What does the word sum mean in math? Total when we're what? When we're dividing, when we're subtracting, when we're multiplying.
It's adding.
The total, what we call the total when we add. Yep. All right. The total when we add. Consecutive. What does consecutive mean?
Plus 1.
Ooh, okay.
Continuing.
Continuing. Good. So both of you guys are right. So 1, 2, 3, 4, one after the other. One after the other. Even numbers. I'm sure everyone knows what an even number is. What is an even number?
2, 4, 6, 8.
Yeah. Right? Those numbers that can be evenly divided, right? So we know that when we add them all up, one after the other, meaning they have to get bigger, right? Even numbers, we get a total of 212. So they want to know what is the third number. So we have to look at numbers that get bigger as we go, right? There's 4 of them. When we add them all together, they equal 212. And the question is, what is the third number? They also gave us, and I'm going to write this out. This is where it's closer to what the test is going to be like. They said, let x. Okay. What's that? Go ahead.
I said word songs are like difficult for me. I don't understand it.
And that's why we're doing it first with the most amount of time, and we dedicate a whole day to it. We always hit the math standards that have the lowest level of proficiency. We always use our time wisely. So the data shows that you would have trouble here, which is why we're starting with it. And they're giving us a pattern. I wrote the pattern out. So let x be the first number. So consecutive, one after the other. X is the first number, right? Then they're saying the second number is x plus 2. Right? They're helping us develop the equation. Right? X plus 4 is the third number. So they gave us a little pattern here. Start off with x, then x plus 2, then x plus 4. And we know the total, they gave that to us. They're telling us the pattern to follow.
Where?
So this is a problem that I'm getting from the HiSET test book. So they're telling us.
No, I don't see where the 2 is given in the question.
Oh, the 2 is given right here. You guys, they gave that to us as additional information. They're letting us know what the order is. The order is that we start off with x, then we go to x plus 2, then we go to x plus 4.
I don't get it.
Okay. They're letting us know the pattern, right? Remember how we talked about a pattern, the consecutive? They're letting us know that the pattern starts off with x plus 2. I'm sorry, they're letting us know that it starts off with x. So it's going to be x. This is the beginning of the pattern. Then x plus then that plus x plus 2, then that plus x plus 4. What's that third number going to be?
But the consecutive pattern could start with 8 and 10 and 12. So
But
we
they're
can
telling us what the pattern
specify-
starts with.
specify
But they're telling us what the pattern starts with. It starts with x plus.
where.
They're telling us that in the problem.
I don't see it.
Here, I'll send you a text of it. They're telling us that in the problem itself. They're telling us where.
So then is the third number 6?
Ooh, how'd you get the third number would be 6? You're exactly right. How'd you get that?
Because you're going by 2. 2,
It's-
4, 6.
And we know that it's
And
a
if that's a consecutive number, then it's 2, 4, 6, right?
correct.
6.
Correct.
So we have to find it for the 212.
Yes.
So I still don't know how you got 2, but I know that it was 6.
They gave us that. They gave us the fact that it was 2. So that was just provided in the problem.
Okay.
Yeah. That was provided to us in the problem. And that's fair in that.
54?
What's that?
54.
Wow, you guys are killing it. Okay, so let's back up. Yes, that is the answer. Let's back up then. All right. And I'm telling you, you guys were ready to test, man. They bring me in just to close it out so you guys go, you test, you pass, and we keep it moving. You guys are all killing it. Even answering the problem before I even finish. Okay, so my friend who answered with 54, let's go ahead and set up an equation. We know that we have to add them all together to get 212. There are 4 sets of numbers. They started giving us the pattern, right? Because we need to figure out what the third number is going to be. So how could we set it up as an equation? They gave us where to start. Where do we start? Okay. So what's the first thing they gave us in the hint? What did they tell us? Let x be the first number, right? So what's going to be the first thing I'm going to write down in my equation?
X. X.
Good.
X cubed.
X cubed.
Okay. So x. Sorry, I was responding. Okay. So x.
Something equals 212.
We know all of this has to equal 212. We're building our equation. Now, they said it was x, right? And what did they say the next number was?
Oh. So wait, 2.
Yes, x plus 2 plus x plus 2. We're going to put in parentheses so we don't get confused. X plus 2. What else?
Oh, Andre got it.
What else?
That's X plus 4. Plus X plus 4.
Plus x plus 4. What else? Sorry.
Plus X plus 6.
Whoa, how'd you guys get x plus 6? You're not wrong. You're right.
That's the third number, correct?
Correct. And you see the pattern, right? 2, 4, 6. And how many numbers do we have all together now?
Makes it.
We have 4 numbers. Right? Now, are they whole numbers? No. They're all equations with variables. But what do they want us to do?
To find X. No?
Not find x. The sum of 4 consecutive even numbers is 212. What is the third number?
To define what equals 212, correct?
Yeah, but they want to know the third number.
Is that still the 6?
No, so what's the third number
Mm-hmm.
has to equal 200.
Well,
We gotta add the x's together, all of the x's together first.
Oh.
yeah, so we need to solve for that, right? So we want to figure out what this third number is going to be. And I like the fact that somebody already knew where to start. So we're trying to figure out what this third number is, but like somebody mentioned earlier, if we find out what the x equals, then we would be fine. So we need to solve for x plus 4.
You have to do everything in the parentheses first, right?
Yes. Well, for the purpose of this, anytime that we're working and we have multiple variables, even if it's the same letter, the same variable, first let's combine everything. Let's combine like terms. Let's combine all the like terms. If I did that, how many x's do I have?
4. If you combine all the x's, 4.
Yep. So I have 4x. So I got rid of my x's.
So we need to add 2, 4, and 6.
Which is going to give you what?
12.
Correct.
12. 4x equals 12.
No, so 4x plus 12.
Oh, 4x plus 12.
4x plus 12 what?
412.
412. Then we could subtract 12 on both sides. Give us
Equals
200.
212. And yeah, take away, deduct 12 from both sides.
So then it will be x will equal 50.
And now we're gonna divide 200 by, yes, you're right, Cole. So now we're gonna divide by 4 on both sides, and x equals 50.
Now, what is the formula for the third number?
50. X plus 4.
Well, we know what x equals, but they gave us formulas for the numbers.
X plus 4 are the sum, right?
Yep.
Plus 4.
So what would the answer be? What is the value of the third number?
54.
Correct.
How is it 50?
What's that?
How is it 54?
Because they gave us the equation that represents each number, right? This was the first equation, second equation, third equation, fourth equation. Figure out, when we know what x is, what value the third number would be.
So we have to add 4 to 50?
Correct. Because now that we know x is 50, then this is no longer an x here. It's actually 50. And 50 plus 4 gives you 54.
Okay.
Make sense?
Okay. Yeah.
Now, this one, I think because of the online component, oh, you're welcome. Because it's an online component, you can't see the problem. You're listening to it and I'm writing it. Sometimes it's hard. This would be a little bit harder to set up than normal because like you're listening and watching and things like that. But that's what we would do. We set it up.
So if it's the fourth, let's say the third problem will be 56,
Correct.
correct?
Correct.
Okay, now makes sense.
So it's 52, 54, 56. So 50, 50. Okay.
Mm-hmm.
We just basically plug the 50 back into the x's in each parentheses.
Correct. Because the x is the variable. It's the unknown. We do that in real life all the time, right? Like, let's say we have like the Raider Stadium. If we sell the tickets for $50 a pop, right? How many people do we need to sell tickets to get, $1 million? Right? So we would work that out. Same concept. So we use those variables anytime we're not sure of what the value of a number is. But here they actually gave us the value.
Okay.
And if we check it, 50 plus 52 plus 54 plus 56 gives us 212. All right, so I know we've had a few students join. And with that being said, I'm willing to go on longer if you guys want to do one more problem, or we can wrap it up here. I'll leave it up to you guys.
More problems.
All right. Okay.
Oh,
For every,
yeah.
okay.
I have to leave early.
Yeah, if you have to go, because the class does end at 12. So if you have to go, go ahead. I will stay on. Same thing for everybody else. If you'd like to continue to do some, go ahead. If you leave early, it's not leaving early. If you leave now, that's not hurting your time because you're only required to be here till 12. So if you want to stay on and keep working, go ahead and do so. If not, I understand. There's definitely a lot of stuff going on. Just please make sure that you also fill out the attendance for the checkout. Again, that's shared with Mike.
I have to leave too. I see you guys on Monday.
See you on Monday.
And I have to check for my
I have to do more attendance.
I'm sorry, what was that?
For attendance, is there anything I need to sign in with, or?
Yeah, so I have a website. I'll send it to you. And the website is just for attendance, really. And then I also post up the YouTube videos from here. So if you want to try the problems again or rewatch it, you can do that as well.
Yeah. And then when this is completely done, is there an option as well to reset to well, that's the attendance thing that I have to.
Yeah, and I do that because like it just makes it easier. I share that with everyone, my bosses and bosses' bosses. Attendance is a huge thing. That's another reason why I try to always make it super easy to access the class. Like some people are like, "Hey, I only have my phone and I'm at work." I'm like, "Hey, even if you just listen, that's fine because the video goes up online, and then you can review the video and try the problems again." Yeah, and some other people said that they would like some more problems.
Yeah, I did. Lydia just me. So by being on this live YouTube, that's my attendance thing. Like, how are you able? You'll send me the link.
Yeah, so I'll send you the link for the website. I do see the participants on YouTube as well, but there's also a website so that you can log it in there and you can be seen by the powers that be at CSN. All right, perfect. Okay, so we'll do one more. Okay. Sorry, I just got an email. Okay, so let's look at the next problem. Okay, so a children's store is selling pants for $6 each. And I might actually finish reading the problem before I write it, but even if you are listening and writing it down, you'll be in good shape. And again, that's definitely a lot harder than the actual test. You'll be able to see it. It's not just going to be your own notes. A children's store is selling pants for $6 each and shirts for $4. Brenda bought 13 items and paid $62. How many shirts did she buy? So I'm going to write this up again. So, a children's store is selling pants. for $6.
$6. So
There you go.
P.
Each and shirts for $4.
And
Brenda, and I love the fact that as you're reading, listening, you are already starting to create those variables and piece together the equation. Brenda bought 13 items and paid $62. How many shirts did she buy?
so how many shirts did she buy? Is the equal amount going to be the 62 or the 13? Because it's saying how many
Ooh, a great question.
shirts did she buy?
So let's break it all down, right? So a children's store is selling pants for $6 each, right? So what I would do, $6, and I'm going to put P for pants, and shirts for $4. So $4 and then S, both unknown, but I would get that. I would write that down to kind of get the blood flowing. Brenda bought 13 items and paid $62. How many shirts did she buy? So yeah, what is the equal? What is this all going to equal?
The equal is going to be how many shirts did she buy? So the equal is going to be equals
Because she paid $62 and she bought 13 items.
going to be items equals items. It says how many, but not the did she buy. She's saying the amount, but not how much of it.
Well, they're telling you how much she bought, right? She bought 13. They didn't tell you how much
Oh,
she
yeah,
bought of
but I'm saying
pants.
about the shirt.
Yeah.
How many, as opposed, that's what I'm saying, is like how many, it's not saying how much, but how many shirts.
Yep. So let's go ahead and start setting up our problem because it sounds like you're pretty much there. Okay. So let's look at, well, actually, you tell me. Do we know how much everything needs to equal? How do we set up this problem?
I'm still figuring the amount of items. So 13 items.
13 items, right?
Yeah.
Mm-hmm. Take it piece by piece. So let's start off with what we're trying to get ultimately. What are we ultimately trying to get?
How many shirts?
Okay.
Right.
And do we know anything else that would help us figure out what we're trying to work towards?
Everything that cost 62.
Good. So everything that we're going to set up needs to equal $62. What else do we know?
So well, we know if you take $6 and you multiply that by 13 items, that would come out to 78. So that's over, right? There's overage.
Yes, there's an overage.
How I'm working out now. If you take the $4 and you multiply that by 13, then that's 52. So it's under.
Mm-hmm.
Well, but you just need you can use just one of those. You can use one of them to figure it out. So
Yep, just like the problem we had with the quarters.
yes, the
Mm-hmm.
Okay.
So going back to that problem, when we're trying to figure out how many items we have out of a combination of things, what do we do with that item and the total number of items?
Fraction
Close.
or dividing? Are we?
Because remember when we were talking about the quarters, right? Since we wanted to find out the dimes, we had to subtract the dimes out of the total number of coins we had, right? That's how we can find out how many dimes we had, how many quarters we had. So in this situation, we're doing the same thing, but we're talking about clothes. So what could I do to set it up so that I know how many out of those 13 items are shirts?
For sure. Okay. What do you subtract the 62? You take 62 and subtract it by the.
Well, we know 62 is the total, and we know she bought 13 items. And what are we trying to find?
I'm off. I'm gonna listen to you now.
Okay.
I'm confusing myself.
It's okay. So we know she bought 13 items, right? And we're trying to figure out the shirts. So out of those 13 items, we need to subtract out the shirts. Does that make sense so far? Remember how we did the same thing with the dimes? We took the total number of dimes. We took the total number of coins and we subtracted out the dimes. We're doing the exact same thing, and you're going to get questions just like this on the test. So we know it all has to equal 62. She bought 13 things. Out of those 13 things, we need to figure out how many are shirts. So we're going to subtract out the number of shirts. Does that make sense so far?
Yeah.
Okay, good.
But that's because what I did is what I'm doing, like my logic. I'm like, okay, multiply thirds, like so they're 4 each. I multiplied 4 times 13, which comes out to 52, and then I subtracted it and it left me with 10. So it leaves me with $10 left over. But, see, I'm confusing myself, I think.
Yeah, so I'm going to give you a formula because you're going to get a lot of questions like this. I'm going to give you a formula that's going to help you anytime you get a scenario like this. We know what weight equals, right? So now what we need to do is take whatever known things were bought or whatever known amount of items we have, we're always going to take that and we're going to subtract it by whatever we're looking for. In this case, we're looking for shirts. In the last case, we were looking for dimes, but it's always the same thing. Anytime they give you a bunch of items and they want you to figure out how much you have of one item, take your total, make it after the equal sign. Take all of the items that you have. We know here we have 13. We're going to put that in parentheses every single time. We're going to subtract that by whatever we're looking for. In this case, we're looking for shirts. What's that?
13 minus 4?
Well, it wouldn't be 4 because we don't know how many shirts we have. So we need to take whatever shirts. Yeah. So do you understand why we're subtracting it by the shirts? Because we don't know how many shirts we have. So we're trying to figure out the maximum number of pants that we can have. So to do that, we need to see the number. To look at the maximum number of shirts, we need to subtract it by our total. and then we need to see the maximum number of pants. So here's how we do that. 13 minus S. Why? We have 13 total items. We're trying to find out the number of shirts. So we're always going to subtract it by the S. So when you see a problem like this on the test, take whatever they tell you the total number of items are, subtract it by a variable that represents whatever you're looking for. Does that make sense so far? Okay. So we know we're looking for shirts. So we know that out of this 13, we're going to subtract by S to figure out how many shirts we have. Now, what about the pants? How much are the pants?
6.
So let's multiply this by 6. Why are we doing that? To see how many pants can we eat. If they were all 13 items were all pants, how much is that going to be over or close to 62? Does that make sense so far?
It's gonna be over. It's gonna be 78.
So we know we're going to be over, right? Yes.
So we're gonna be over. Yes.
Yes. Now, do we know how much each shirt cost?
$4.
So this is going to help us figure out our overage. But we still need to know that for every shirt, she's paying $4. Does that make sense so far?
Yes.
So I'm going to give you a little formula because, again, you're going to see a lot of them like this. Anytime you have a problem similar to this, find out what everything needs to equal. That's your first step. That's what everything needs to total out to be. In the parentheses, and you're going to do this pretty much every time without exception, take your total number of items and then subtract it subtract that by whatever you're looking for, right? So in this situation, we're looking for shirts. So we're going to subtract that by shirts, right? Does this make sense so far?
Yeah.
All right, subtract that by whatever you're looking for. Now, because they're going to a bunch of problems like this, the other item is never going to go evenly into your total. That wouldn't make sense. So we're going to multiply this by the other item. So we figure out the max number that we can get out of the other item. Does that make sense?
So the other item, yeah. So that's like multiply 6 times the amount of pants. Multiply that by the amount of 6 times. That makes it 12. That's the highest it can go into. So like 12 for pants. The amount of items is for pants. 72 plus. No.
You're on the right track. You're exactly right. If we figure out what would happen if they were all pants, then it's going to make it easier to figure out what the shirts are. And that's what this is doing. That's why it's an equation we can follow every time. We're going to take whatever amount of items we have in total, and we're going to subtract that by a letter that represents whatever we're looking for. Does that make sense so far?
Yeah.
Now, because I know that the pants are too much, I'm going to multiply all of that by whatever I'm looking by the other item. Why? Because this is going to let me know how much the other item would make everything cost. So if all 13 items are pants. I'm sorry, who was that? Hello?
What do you mean?
Oh, okay. All right. Does that make sense so far?
Yeah.
Okay. So explain it back to me because I think we can solve this. I think we're comfortable with the function. So explain back to me why we set up the problem this way.
Well, because we have the amount, the equal is the $62,
Mm-hmm.
and then the amount of items was 13,
Mm-hmm.
and we're trying to figure out what the amount of shirts are, and we have to minus that, right? We have to subtract that.
Correct. And why do you think we're multiplying the 13 by the 6?
We're multiplying that so we can figure out the distance.
Yeah, exactly. Right? Because if we know that all of these are pants, then it's going to, if we see, okay, if all of these were pants, this is what it would cost. And then that lets us figure out what the maximum number of pants are. And if we know what the maximum number of pants are, then we can figure out how many are shirts because it's everything that is left over. There we go. Does that make sense?
Yeah.
Okay.
Mm-hmm.
So let's go ahead and solve this. So and this is going to be now a review again of equations and solving for the variable. So what could I do here?
Multiply 6 by the largest number that can go into 62 for the pants, right?
Well, here now we set up the equation, right? So now we need to figure out what the variable equals. And what's our goal anytime we're doing these and we're trying to figure out, anytime we're working these equations, what's the ultimate goal?
Your green pause. Got it. Okay, back to normal. I'm not sure. I have to see how you work it out for me to be able to
Okay, so there's a magical rule. And the rule is that we need to get the variable, the letter, all by itself and get all the numbers on the other side of the equal sign. Does that make sense? We need to get all of them alone. Does that make sense so far?
I'm making sense, but I'm following, just following. If I feel like if you figure it out in front of me, I'll be able to figure out what it is.
So our goal is to get the S completely by itself.
Okay.
So the first thing we want to do is combine everything that is the same. Right? So we have a positive 4S and a negative 1S. So let's combine those. What's that going to give us? 6 times 13. Negative 1S plus 4S gives us 3S equals 62. So what do you think we're going to do here so we can get the S by itself? We have a whole bunch of other things that we need to get rid of.
Multiply?
Oh, but we still have this S over here. Well, we could multiply. And what are we going to multiply?
Well, why is that a 3S now?
Because we combine the 4S and the 1S. And this 1S was a negative S.
It's negative. Okay, stop. So we So are we still continuing to multiply with 6 times 13 and then
Correct.
that has to go first, so that makes it 78. But you're not at. No, I don't know. I'm like.
Okay, and looks like
Figuring it out.
what's that?
The way I was figuring it out, like I feel like it's just much harder. I'm making it. I'm having to think more, and it's
Okay, so let's start back at the beginning. So, what could we do to simplify all of this? Could I combine? And Mariana, are you on the conference call as well? Oh, so she's just on the video. So the first thing we want to do is combine like terms, and we could do that in a couple of different
Hi,
ways.
can you show me?
Oh, yes. Is that Mariana?
Yes, I'm Maria.
Okay. All right. So why don't you help us out? What are we going to do here?
Okay. I multiply 6 for 15, and then 6. I got 78 and 6f.
Okay, keep going.
Then I passed 88 to the other side.
Okay, so I'm actually going to walk it. I'm going to write it out as you're saying it. Okay, so let's start from the beginning. Sorry, I just got a message. Okay, so we have 6 times 13 subtracted by s plus 4s equals 62. So what did we do from here?
Yes.
Go ahead.
Okay, I multiply 6 for 15.
By 13?
And yes, and 6 for minus 8.
Okay. And what does that give us?
Then, sorry?
And what does that give us?
Okay, 6 for 15 is 78. Oh, sorry, 78.
Uh-huh.
Yes. And minus 6s.
I'm going to make the S in a different color because I know it can be hard to tell that it's S and not a 5.
Yes, then I passed the 78 to the other side, and I subtract the.
What about my 4S?
I'm sorry?
What about the 4S?
Fine.
Do I bring the 4S down?
Yes.
All right.
Okay. Then I had the 6s equal to 8. Sorry, to minus 16.
Okay, so once we're here, what do we do?
And okay.
Do you guys, los dos hablan español? Because I don't know if you're more comfortable in one over the other. Because for this, it's just about computation, right? So when we get here, it's about being able to solve it. So if you can't explain it in English, I don't really care about that. I just care about being able to understand the concept because they're not going to test you on your ability to explain it in English. So, I mean, if it's easier for you in Spanish, that's fine. Bien, porque aquí esta prueba es sobre matemáticas. Entonces, si me puedes explicar en español y también te entiende Lidia, eso es la gracia. You okay with that, Lydia?
Okay. Yeah, I'm cool with it.
All right, go ahead. Okay. Aquí, entonces.
Ok, lo que yo hice fue multiplicar 6 por 13.
Multiplicar,
empezando con el 13
ujú.
y después y 6 por 5 por S, perdón, S.
Sí.
Entonces yo obtuve 78 menos 6S
Ajá.
todavía, y luego más 4S igual a 62. Después yo eliminé 78, bueno, los paréntesis, luego pasé 78 al otro lado del signo igual, restándolo a 62.
Okay. So we're going to minus out 78. Ajá.
Ajá. Y me quedo del lado izquierdo menos 6S más 4S. Y luego, sí. Y luego lo que hice fue hacer la resta. Menos 6S más 4S. Me quedaron 2S. 2S y igual a menos 16. Después dejé la S sola, la variable, y pasé dividiendo el 2, el menos 2 en este caso, menos 2. Entonces, como tengo menos 16 dividido entre menos 2, me da un número positivo y me queda 8.
Did that make sense, Lydia? What's that? Okay. How comfortable do you feel with word problems and with equations? Be 100% honest because we got nothing but time.
I feel like they're like this whole like so she subtracted when she subtracted the minus 78 and on that side, and then on the other side, I feel like these are ways of doing this that's like an equation that I just a rule that I'm not following. Like I
Okay.
if that makes any sense.
Yeah, no, it does.
So on a scale of 1 to 10, all of this I'm like about probably a 6.
Okay.
So,
So one of the things you want to keep in mind whenever you get to these equations is the goal is always to get the letter by itself. So you're going to do the opposite on one side and the other to try to get everything to cancel out. Does that make sense? So because we had 78 minus 6s plus 4s equals 62, our goal is to get rid of everything except for the s and get all the numbers on the other side so we know what the s equals. Does that make sense?
yeah.
So why do you think she subtracted 78 on this side?
Well, isn't it to get just closer to the
Yep.
just having
So she did that to get rid of it. So see how I crossed it out here? So she got rid of it here. But if you do it on one side, you got to do it to the other side, right? Now, do you see how then we were left over with 6s plus 4s equals negative 16? Did that make sense?
No, sorry, I was thinking about something else on how like I figured out because I came to the 8 as well, but
Okay.
I came to the 8 in a much more complicated way that just could have been.
And that's okay. The ultimate goal is to pass. The ultimate goal is to pass. So even if it takes you a little bit longer, how did you get to 8?
What I was initially saying, just like, because I got to remember, I don't know if you remember, I mentioned I was like, if you minus the 78 by the 62, that leaves you with 16, right?
Correct.
And then, and then. And then 16 That comes out to 32. If you multiply that by 2, it comes out to 32. And now I'm math all messed up.
Okay.
But
So if we get here, we subtracted out the 78. You understand how we got here, right?
yeah.
Okay. So we got rid of the 78. What else now do we have to get rid of?
Now we have to. The next thing is the 6, right?
Correct. The 6S and the 4S. So how can we get rid of those?
By isn't it just like canceling each other out?
Yeah.
Like just out the corner, they cancel each other out.
Yeah, because -6 plus +4 gives me what?
2
And what kind of a 2?
positive.
Well, think about it this way. If you're -$6 in the
-6
there
plus
you
four,
go.
so it's a -2.
Correct.
-2. Got it.
So yeah, -2S. We got rid of the 6. We got rid of the 4. We're down to -2S equals -16.
I see. And then canceling it out again.
Correct.
Okay.
Make sense?
Yeah.
All right. Would you guys like another problem, or you think you're comfortable for today?
Great for
I
today.
think-
I'm going to send over questions, and I'm going to, if you can please message me like your direct email, and then that link you were going to send me, I want to send over
Yes.
all my questions and concerns to you. And am I able to? Am I able to? I have to text you through this Google thing, or am I able to text you through the phone?
As many different ways.
Communication.
As many